Hello, my name is AJ and welcome to my channel. So as a part of this series, we are going to see a very important concept in automation testing, that is Selenium Grid with the Docker. So I am going to cover some basic idea about the Selenium Grid, what exactly it is, what are the advantages of Selenium Grid, why we use it, and we also required some basic knowledge about the Docker. Okay, so I'll be covering some important concept about the Docker. So it doesn't matter if you are at a beginner level watching this video, you are going to understand everything from this series. Okay, so once you understand Selenium Grid, what exactly it is, what is Docker, then we are going to practically implement this Selenium Grid architecture with the help of Docker. Okay, so we are going to set up our Selenium Grid with the Docker practically, and once it is done, we are going to run our Selenium test cases on this grid. Whatever Selenium Grid architecture we have created with the Docker, we will be running our multiple Selenium test cases on that grid. So we'll be running in a parallel on different browsers, Chrome, Firefox, Edge. We will see how we can run the test case one by one, or we can run the test cases simultaneously in parallel mode also. And at the end, we will see how we can configure, how we can set up the Selenium Grid architecture with the help of Docker Compose YAML file. Okay, so let's get started. So first thing we are going to see is what is Selenium Grid. So let's see some basic idea about the Selenium Grid. So Selenium Grid is the Selenium component which allows you to run your test cases on the remote machine. So we normally create WebDriver reference, right? WebDriver equal to new Chrome driver, right, for Chrome browser. So that test case you are running on your local machine, right? But what if I want to run my test cases on some remote machine? In real time, in the company, we have 100, 500, thousands of test cases. So what we want to reduce the test case execution time. So for that purpose, what we do, whatever 100 test case we have, so let me show you this through the paint for better understanding. So let's say I have 100 test cases. So if I run all these 100 test cases on a single machine, on your local machine, let's say it takes around 3 hours. Okay, it takes 3 hours. So what if there is some configuration I can do, some setting I can do, so that I can run all these 100 test cases within 10 or 20 minutes. My ultimate goal is to reduce the test case execution time, and I will get the result as soon as possible, and I can work on the bugs. Whatever bugs we will get by running these test cases, we will get more time to fix it and more time to test it. Okay, so our ultimate goal is to run all these 100 test cases within less time as possible. Okay, maybe 20, 15 minutes, half hour, right? So normally it is going to take 3 hours. So what I am going to do, I will have some configuration. I will create some setup so that I can run all these 100 test cases on the different machine at the same time in parallel mode, right? So there will be different machines connected in that setup, and they will run 100 test case. Means I will distribute some of this test case to one machine. So one machine is going to run 10, then another machine is going to run the 10 test cases, right? Likewise, I can divide this 100 test case. So whatever result I was getting in 3 hours, I am going to get it within the 15 minutes, right? So isn't that amazing? By doing this kind of setup, we are reducing our test case execution time to 10% only. So whatever 3 hours it is going to take, it will directly reduce to the 15 or 20 minutes, right? So that is the main advantage why we use this Selenium Grid concept, Selenium Grid. So it will allow you to run your Selenium test case on the remote machine in parallel mode. So we can run our test case on the different browsers as well, right? In testing, we need to test our application on different browsers, different OS, right? So there can be our Windows, so we run our test case or application on Windows machine. Then we can have Linux also, we can use the Ubuntu, right? We can run our test case on the Mac, and we will have some different browsers. Like we want to run the test case on the Chrome, then we will use the Firefox also, then Edge. Like there are different browsers on which we can perform the testing, right? And manual testing also we used to perform on different OS, different platform, different browsers, Edge, Safari, and all these browsers, right? So in automation also, what if I will have some setup with the help of the Selenium Grid, so that whatever test case I have in my project, I can run on all these browsers simultaneously in parallel mode, and I will get the result as early as possible. So that whatever issues I will find, I will get more time to fix it in a development, and I will get more time to test it again, right? That is the main advantage of this Selenium Grid. It reduces the test case execution time by running the test case on the different platform, different browsers simultaneously, right? So now next thing is to see how the Selenium Grid is allowing connecting these multiple remote machines and running some test cases in parallel. What exactly is there in the Selenium Grid? Okay, so let me show you that. So this is the basic architecture of the Selenium Grid. So in Selenium Grid, what we will have a hub. Okay, so this is, you can consider as a machine or a host machine which will act as a hub. Okay, so this hub is going to accept all my Selenium test case requests. So what I will do, I will provide my 100 test case to this hub. Now hub is not going to run our test case. Okay, hub is just an host machine. Consider it as a server, and it will have some client machines connected. Okay, so this is my one machine, this is my second virtual machine. Okay, so consider this machine as a virtual machine as of now. Okay, so these machines are connected to this hub. Okay, there can be different machines. So one machine, you can consider this as this machine is running some Chrome. So consider this machine is running, let's say Windows, then browser it is running is Chrome, then I will have a second virtual machine running same let's say Ubuntu. I am going to run test case on Firefox. Okay, then it can be your Mac machine. Okay, so you can connect any kind of machine, okay, any platform machine, and you can have different browsers. Okay, whatever browsers you want to run the test case, you need to install that browser on that virtual machine. So these machines are called as nodes. Okay, so you can also call them as client also. So this is my hub, or you can say it as a host, and these machines are called as clients. Okay, so these are the clients. So you can have multiple nodes connected to this common hub, okay, common host. Okay, so you can have these multiple machines. So all these machines are connected to the common host. Okay, so they are ready to serve this host. So whatever request this host will send, it will perform the exactly same work whatever host is asking. Okay, so what I will do, I will provide my 100 test case to this hub. Okay, and according to the request type, like I send the request that I want to run my test case on the Chrome. So this hub will send that request to this machine, node 1, and this node will perform your testing on the opening the Chrome browser. Then second request I want to run on the Firefox, it will run on the Firefox, then Safari, and there can be test case we are running on the multiple browsers at the same time, Chrome, multiple Chrome at the same time, multiple Firefox at the same time. Okay, so consider in this architecture we have created, let's say I have created 5 machines running Chrome browser. Okay, so we have 5 Chrome machines, then we have 5 Firefox and 5 Microsoft Edge browser. Okay, so what hub will do, hub have 100 test case to run. Okay, so hub what will do, hub will provide 5 test case to be run on Chrome. It will send to these 5 nodes running 5 Chrome, then it will send other 5 test case to this Firefox, then it can send other 5 test case to this Edge browser. That means at the same time 15 test case are running in the parallel mode. So test case execution time when you are running on the local single machine, which is around 3 hours, is reduced to again half hour. Let's say only half hour you got the result. So all the 100 test case got executed within the half hour, right? So this is the biggest advantage of the using the Selenium Grid. It reduces the test case execution time by running your test case in parallel on different machines at the same time on the different browsers. Okay. So how you create this hub and node architecture is completely up to you. You can use the physical machines to connect to each other, or you can use the virtual machines also. Okay. So main advantage we have here is by running our test cases on the different machine in parallel mode. So you can have physical machine or you can have virtual machine. But in terms of physical machine, it's going to cost you a lot, right? For physical machine. So we use the virtual machine. So creating this hub and node architecture, Selenium Grid architecture with the help of virtual machine is also not a cost effective. Okay, that much cost effective. It is going to cost you a lot. So that's why we come to this concept, Docker concept. Okay, so what is Docker? So let me give you a basic idea about the Docker, and then you will understand why most of the companies are nowadays they are using the Docker containers for creating this hub and node architecture, Selenium Grid architecture for running the test case in parallel. So Docker is an open source platform or technology by which we can develop, test, ship or deploy our application as a container. Okay, so by using the Docker, we can develop any application and we can ship that application into a container and we can deploy that anywhere. Okay, so main advantage of Docker and why we use Docker is, let's say in a software company, we developer create the application in the dev environment, right? Okay, they perform some unit testing after completing some functionality or feature. Then they provide that application and deploy that application to the QA environment, let's say. So this is my dev environment. Okay, dev environment, and this is my QA environment. Okay, so QA will perform testing in this QA environment. So these environments are different, right? So there is always a fight between development and QA that some feature or functionality which is working in the development machine, so developer's environment, which is not working in the QA environment. Okay, so normally this fight happens. So this scenario is very common between developer and QA. So by using the Docker, we completely remove this scenario. We completely remove this fight between developer and QA environment. So using the Docker containers, what developers are going to do is they will create the application, they will develop the application, and whatever files, code files or supporting configuration files, there will be some jar files required, dependencies, right? So whatever files are required, they will keep all the libraries files. So all the things to run the application and run that feature will be available in this form of container. Okay, so all the things are there. So what developer will do, once application is done, development is done, same container will be provided to the testing team, right? So same container is there for the testing purpose. So whatever supporting libraries, supporting configuration files are required to run that application or run that feature, are there in this container. Okay, so same container or Docker stacks will be given for the testing team to perform the testing. So testing can be performed on the same Docker stack. Okay, so you can consider this containers as a virtual machine as of now. Okay, so this is nothing but a container. So virtual machine and container, only the big difference between these two is virtual machines have the OS running. Okay, so they will have their own OS, but these containers will not have any OS. Okay, they will share the host machine resources. That can be your OS, that can be your RAM, hard disk space. So container will not have their own operating system. Okay, so OS is not available here. And they are going to consume the memory or RAM, whatever required from the host machine only. Okay, so another big advantage of the Docker containers as compared to virtual machines are these containers are very lightweight. You can create and run these containers whenever you are required with the help of very simple Docker commands. Okay, so in case of virtual machines, you need to do all this setup configuration on the virtual machines, whatever software applications you require, you need to install it. It will going to take the time, and whenever we require in virtual machine, you need to start that machine. Okay, so that starting time for the virtual machine is very high as compared to Docker container. And once our work is done, we need to shut that virtual machine. So whenever you require that virtual machine again, you need to start that machine again. It is going to take the time. Okay, so that process is time consuming and complex as well. So in case of Docker container, whenever we require any container, you can very quickly we can create the container and take it up. And when our work is done, we can take that container down very easily. Okay, so this process is very fast in case of Docker container. That is the important advantage by using this Docker container. So in case of application development as well, there can be multi containers. Okay, one container running your website, one container the product services or different services required to run that application. Okay, so this can be a multi container application, and you can very much easily take these containers up. You can very easily link this container to each other so that it will works properly as application. And whenever you are required, you can you just have to use the Docker Compose file where you can mention everything, whatever services you are required, in which container you need to run that services, in which container you need to run the website, and you are going to link these containers to each other. Also you can mention the ports and volumes required. So everything can be done in a single Docker Compose file, and your application will be running up within less time. Okay, in case of application development. But in automation testing, we require these containers for the testing purpose. We will require to create the hub, these nodes, and we will run our test case on these containers. Okay, so coming back to our point, how Docker is going to help us for creating this Selenium Grid architecture, hub and node architecture effectively. So with the help of Docker, what you have to do, you just have to install the Docker in the system, and top of that Docker or Docker engine, we will be able to create multiple containers. Okay, so for this Selenium hub, we will create an Docker container. So this will be our one Docker container. Okay, so this is our Selenium hub, and this is our container number one, container one. So this is our one container, and same for creating these nodes, we can create multiple containers. So this is my container number 2. Okay, so this container will be running Chrome browser. So this is my Docker container 2. Okay, this is my Docker container 2. Then I will create another container running Firefox browser, then another container running Mac or Safari browser, another container running another Chrome browser. Okay, so I can create multiple containers with the help of the Docker. Okay, so you can create multiple number of containers here. So all these are our containers, which will be connected to a single host or single hub, right? So this is my Selenium hub, which will accept the test case request. Okay, and it is going to forward this request depending upon the browser type. Okay, so it will whatever test case you want to run on the browsers, Chrome browsers, it will send to the Chrome running containers. Okay, so let's say these containers are running Chrome, it will send this request to the Chrome. Then for Firefox, we can have a multiple containers, so it will send that request to this containers running for Firefox browser. For Edge, we will have some different containers. So all these test cases are going to run in a parallel mode. Okay, and our test case execution will be completed in very less time as compared to the running WebDriver on the single machine, right? So let's start with our session number 2 in this Selenium Grid Docker series. So in this session, we are going to set up our Selenium Grid by using Docker practically. So in last session, we have seen some theoretical part about the Selenium Grid, what exactly it is, why it is useful in the automation testing, and we have seen why Docker plays a very important role in this Selenium Grid architecture. Okay, so let's start. So this is a basic architecture of a Selenium Grid configuration where we will have a Selenium hub, okay, this one, and we will have some nodes connected to this common hub. Okay, so these are our nodes. So as we are going to use the Docker for creating this Selenium Grid architecture, each component in this architecture will be a Docker container. So this hub machine will be a Docker container, and I will expose any port for external connectivity so that we can run our Selenium test cases on multiple browsers simultaneously using this structure. So I will expose let's say port number 4445 for the Selenium hub. Okay, and these nodes will be also my a Docker container. So I will create separate container for each node. So this is my Docker container 2, and we are going to see what exactly happening on this browser using VNC. By using VNC application, we will be able to connect to this each node. Okay, and we will be able to see what exactly happening on the browser, how our test cases are running. So here you can expose any available port. So here I will, let's say, port number 4446. Okay, so VNC service always run on this port number 5900. Okay, so if you want to see what exactly happening on these particular nodes on the browsers, we need to expose any port. So it will keep listening to the same port 5900. So we are going to expose this 4446. So for each and every node, I will be required to create a Docker container. Okay, so similar to this Docker container 2, and we have exposed this port, we will create a Docker container 3, and we will export some port 4447. And for this machine, we will export 4448. Okay, so for every component in this architecture, we will have to create the Docker container. So once these Docker containers are ready, we need to link them to each other. Okay, this means that means we need to link these nodes, node containers to this hub container, so that they will be able to communicate each other. Okay, so this will be a bidirectional flow created once you link to the hub, and whenever you give any test case to this hub, hub will check whatever node available as per the browser type, and it will just forward that request to that particular node, and that node will execute our test case on that particular browser. And that's why we need to link this together. Okay, and another important point is while linking, you need to make sure that all these containers should be run in the same network. Okay, if it is a different network, then you won't be able to link them. Okay, so all these containers should be in the same network. That is very important point. Should be in same network, right? Then only we will be able to create a bidirectional flow between these nodes and hub. If they are on the different network, we won't be able to link them, and we won't be able to run our test case, because we need to link these nodes to this single hub. Okay, common hub. So if they are in different network, we won't be able to link these nodes to this common hub. Okay, so you need to make sure they are running in the same network. That I will show you. So let's go and see how we can create this Docker Selenium Grid by using the simple Docker commands. So let me start the PowerShell. Okay, so before you start running the Docker command, you need to make sure that you have Docker installed in your system. Okay, so that you can check using this Docker conversion. Okay, so that means I have Docker installed on my system. So if it is not installed in your system, what you have to do is just go to this docs.docker.com, and there you will find this install Docker Desktop on Windows. Okay, so this Docker Desktop is just an application which will provide you the UI to start any container, stop the container, or delete the containers. Okay, so it is very user friendly. So you just have to install this on your system. So just click on this link, and it will download an .exe file and complete the installation. So before you start running the Docker commands in the Windows PowerShell, what you have to do, you need to start that Docker Desktop once it is installed. So once you start this Docker Desktop application, it will look like this. Okay, so it will contain different things here: containers, images, volumes. So if you see this green, that means Docker is running. Okay, so now we can run our different Docker commands. Okay, and just we have seen that we need to create the Docker containers for each and every component. So Docker containers are created from the Docker images. Okay, so if you want to create a Docker container, you require a corresponding Docker image for that. So if you want to create a container for the Selenium Hub, we will require the Selenium Hub image. Okay, so from that Selenium Hub image, we will be able to create this Selenium Hub container. Okay, so it is required to pull the image, Selenium Hub image first, and we will require the images for this node browsers also. Okay, so let's go stepwise. So first step is to pull images. Okay, so this is your first step. So we require images for Selenium Hub, then Node Chrome debug, then another is Node Firefox debug, and this is the Node Opera. Okay, so currently I do not find the debug image for this Node Opera, but you will find the debug image for both Chrome and Firefox. So using this image, we will be able to create container, and once you expose any port and we will connect through the VNC, we will be able to see what exactly happening on this Chrome and Firefox. So let's go and pull these 4 images. Okay, so let me show you how we can pull the images. So for that purpose, you just have to go to this hub.docker.com. So here, this is an repository where all the images are available publicly. Okay, so you can download any image from this. So just click on this explore, and in this search, you just have to type what image you want. So currently I want Selenium Hub image. Okay, so if I search this, you will find, okay, this is from the Selenium. You just have to click it, and they have given the instruction that how we are going to pull this image by using this Docker command. So this is very simple Docker command, Docker, then pull, and what we are going to pull, I want to pull this image. So this is the image name. Okay, so you just have to copy this image, go to Windows PowerShell, and we will paste here. Okay, so once you press enter, it will download the Selenium Hub image. So as I have already downloaded all these images, it will show you the status that image is up to date for this Selenium Hub latest. So this latest is nothing but a tag. So every image will have some tag associated with them. Okay, there will be different versions. So this tag represent the different versions. So if you want a particular version of the image, you just have to mention it here. So we have not mentioned any tag here, that's why it has taken the latest by default. So it will pull the latest image. So where this image will be available, if you open the Docker desktop application, if you go to this images, so in this tab you will find all the images I have downloaded. So I have Selenium Hub, then Selenium Node Chrome debug, then Node Edge, Firefox debug. All these images I have already pulled. Okay. So what we have done now is we have pulled this Selenium Hub image. So what we have done is we just use this command. So for Node Chrome debug, you just have to use the same command. You just have to use this image name. So I am going to pull this image. So instead of hub, I will write like this, and similarly for Firefox as well. So for pulling all these images, you just have to run these Docker commands. Okay, so let me show you one of it. So let's see, I have already downloaded it, but let's run it again. Okay, so it is going to use the by default latest tag. So it will check if this image is available locally or not. If it is available, then it will show you the status that it is up to date. And if it is not there, then it will go to that hub repository and it will pull that image, corresponding image. Okay, so you just have to run these commands in your case. So once you got all these 4 images on your local machine, next step is to start the network first. Okay, so as I said, we need to have all these containers running in the same network so that we will be able to link them to each other. Okay, so here you need to start the network. Okay, so for that purpose, we need to run this command, docker network create, and here you can provide the network name. So I will provide like grid network. Let's say grid network. So this is my network name. So same name I need to use while running creating these containers. Okay, so this is going to our second command. So we'll just run this in a PowerShell. Okay, so this is the ID. So our network is ready. So next step is to start these containers. So this is the third step, create and run the containers. Run the containers and link them. So first let's start the container for our Selenium Hub. So what we have to do is, for that purpose, you just have to use this command. So this is for hub. Docker -d means it will run in background, then -p that I am going to expose any port for external connectivity. So we have seen that we are going to expose 4445. So 4445 by default port is 4444. Okay, then network. So here you need to provide the in which network you need to start the container. So we just created this grid network. So you have to give this same name here, then -name. So what should be your this container name? So I will give name as my Selenium hub. Okay, so this is my container name. Then which image you are going to use? Okay, so container are created from the image that we have seen. So which image you are going to create for this Selenium Hub container? So I am going to use this image. So this image is already available on my local machine. So if it is not, then it will check the locally first it is available or not, and if it is not available, it will go and download the corresponding image from the Docker Hub. Okay, so you can directly run this command also. If you don't want to pull these images separately, you can directly run this command and it will go and pull this image first, and then it will start the container out of it on this, and it will start running on this 4445. Okay, so everything can be done in this single command, but we are going to stepwise. Just an beginner level, we should not use the shortcuts. You need to understand this concept. So first you need to pull the images, okay, make them available locally, and then we will start our containers. So this is for the Selenium Hub, and I think I missed the important part here, Docker run. Okay, so you need to do the Docker run, and it is going to run the container out of this Selenium Hub image. So let's run this command now. Okay, so this is the container ID that is generated, and if you go to the local host, so we have exposed this port number 4445. So just go to your browser, localhost 4445. You will be able to see that Selenium Grid is up and running at this port. Okay, and if you want to see the console, just click on this, and here you will be able to see all the nodes connected to this common hub. So currently we do not have any node container linked to this hub, that's why it is blank. Okay, so let's go and create our node containers. So for creating the node containers, you have to use the similar kind of command. So this is for node. For node, you have to use the same docker run. -d means it will run in background. -p, so here I am going to expose any port. So I am going to expose 4446 for Chrome node. Okay, So the port I am going to expose is 5900 here. The VNC service always run. So this is the 5900 VNC service port mapped to 4446. So that we will be able to see whatever happening on that Chrome browser while connecting to the VNC. And here I need to run this node containers in the same network as that of hub. Okay, so Selenium hub is running in this network, so I need to run all the node containers in the same network. So grid network. Okay, so here I will provide some name. So this should be my container name. So let's say Chrome node, and image from which I need to run this container is this image, Selenium node Chrome debug. I'll just copy that here. Okay, so if you run this command, it will just start the container, the Chrome node container. So it will not link to this Selenium hub. Okay, so for linking this node to this Selenium hub container, we need to provide the environment here. So after network, I will provide some environment. Here is the hub underscore host. So which host container you need to link this container, the node container. You just have to provide the name of that container. So this is my hub container name, Selenium hub. So equal to this. So what this command will do, Docker run, it will run in background, and this port will be export for external connectivity so that we will be able to see in the VNC. And this is the same network as that of the hub. And we have given here the hub host equal to Selenium hub. That means this node Chrome container will be linked to this Selenium hub. Okay, so that we will be able to run our test case, because Selenium hub is not going to run any test case. It will just forward the request to the corresponding nodes, whatever available. So we have linked this Selenium Chrome node to this Selenium hub, and the name of the container should be Chrome node. And what image we are going to use for creating this Chrome node container is this node Chrome debug. So this image is already available locally, right? We have already downloaded it, but Docker will always check if it is available or not locally, and if it is not available, it will go to the Docker hub and pull that image. So now let's go and run this command. This is our second command for Chrome node. Okay, so container has created, and this is the container ID. And same you can see in the browser now. If you refresh the page, so you can see one node running the Chrome browser has been linked to this Selenium hub running at 4445. Okay, so you can see the browser details, configuration details also, browser timeout, and all these things. Okay, so these are the default capabilities set for the browsers. Okay, so we will see more in detail later. So currently we just have to link our containers. We need to create the node containers and link to this common hub. So our Chrome node is ready. So let's go and create our other containers for the other nodes. So same command you need to use for Firefox. So Firefox, you need to use the same. We will just change the name. So this is my Firefox node. This is should be my node name, and what image I am going to use is node Firefox debug. Yes, so from this image our Firefox node will be created, and we just have to change the port also. So Firefox should start at this 4447. Okay, so at 4445 we have Selenium hub, at 4446 we have one of the node, the Chrome node, and at 4447 we have the Firefox node. So this Firefox container will be created, and it will be linked to the common hub host equal to Selenium hub. Okay, in the same grid network. Okay, so you need to remember these 2 points. So let's run this as well. Okay, so within a few seconds we got this container up and running, and this is the container ID. And if we go and check in the browser now, we have this another container running and linked to this Selenium hub. Okay, so this is our Firefox browser, this is our Chrome, and let's start the third one as well. So some small changes, I will change the port 4448. Then I should start in the same grid network, same Selenium hub, and I will give the node name as Opera node. And what image we are going to use is Opera node dash Opera. Okay, so this should start our third container. Okay, so let's go and see the console now. Okay, so you can see now we have the Opera driver also here. Okay, so now we can able to run our test case on these multiple browsers simultaneously in parallel mode. Okay, so all these node containers are linked to the common hub. That's what we want. So this is the grid architecture, the basic architecture, and we have configured this Selenium grid architecture using the Docker containers, using the very simple Docker commands. So these Docker commands are very easy to remember. Okay, and if you want to see all these containers are running or not, that you can see in the Docker desktop application. So just go to this containers tab, and here you will be able to see this Selenium hub. This is my container name running at 4445. This is Chrome node running at 4446. Firefox node container 4447 and Opera node at 4448. So all these are the running containers. You will be able to see the status also. Okay, they are up and running. So using this buttons, you will be able to stop the container, or you can restart it or delete it for each and every running containers. Okay, so this is the UI provided by this Docker desktop application. And through the command, if you want to see what are the containers or what are the services are running, you just have to use this command. Docker ps means running services, and e means all the services which are running or not running. So you'll be able to see that. Okay, so you will be able to see this is the container ID node Opera. So you can see here 271c is my Opera node, Opera container. So same container ID is here. The image name that we used for creating this container is Selenium node Opera. This is the command and created 2 minutes ago, and it is up and running from 2 minutes. And this is the port we have exposed, 4448 Opera node. This is the container names: Opera node, Firefox node, Chrome node, and Selenium hub. So here first we just created the Selenium hub, and then we created this node containers, and we link this node containers to this common hub in the same network. And that's why we are able to see in this console also. So if they are not in the same network, you won't be able to see this structure here. You will be able to create the container that will be up and running, but you won't be able to link these containers to this Selenium hub if it is not in the same network. Okay, so you just have to use this command for creating this structure. First pull the images and then start the network. So give the network name, and same network name you need to use while creating these containers. Okay, so very simple, and whatever port you need to use, you can provide the number here. And here one more thing I want to show you, that if you don't want to provide user defined port here to expose, you can ask Docker to run or expose any port available. Okay, so you just have to make a small change in our command. So let's create another Chrome node with that command. So here what we have to do is, instead of this, what we will do, we will just have to give here capital P. So what this command will do is, it will open create a container with the name equal to, let's say, Chrome node 2 in the same network, and link to this common hub, Selenium hub, and it is going to expose any port available. So we have not provided any particular port number here. So we have given the capital P here. So whatever port available at that time, it is going to expose it. Okay, so let me run this also, and we will see. Okay, so name should be different because we have already created a one container with Chrome node. So I have changed the name, and here is the capital P. So another container has been created, and that is linked to hub. So now if you check the services, Docker ps space -a, now you will be able to see Docker has exposed this port 49153. So this is the port which was available at that time. So Docker itself exposed this port, and we can use this port number while connecting this node through the VNC. Okay, and for other nodes we need to use this port number 4448 for Opera. For Firefox we will use 4447, and for Chrome first node we will use 4446 in the VNC app. And if you refresh the page, now we will have two nodes. Okay, two nodes with the Chrome browsers, and I can show you through the VNC also. Let me open the VNC app. So all you have to do is just download and install this VNC viewer from the Google. It is very simple, and once you open it, you just have to type the IP here, the machine you want to connect to. So our IP will be the local machine IP, so 127.0.0.1, and here we need to give the port number you want to connect to. So let's connect to this first node, the second Chrome node. So its IP is 49153. 49153. Okay, if you hit enter, it will ask for the password also. So yes, here you just have to give the secret in lowercase. Okay, and click on OK. So this is the container running. This is the Linux container running our Chrome browser. So when we run our test case, you will be able to see that browser is opening, and whatever test scenario you are testing, that will be able to see visibly here. Okay, so that will help you in the debugging process also. So this is our Chrome node 2, and if you want to connect to other nodes, so other nodes are 4448 Opera node, 4447 Firefox. So you can easily connect to those also. So you just have to change the port number here. So 4446. Continue again. Here you need to do the secret. Okay, so this is our second, right? We have two windows now, and the third one we will open 4447. So these windows will show you what exactly happening inside that container, what are the actions that we are performing on the browsers, on the application. You'll be able to see all those here. So I think that is all for this session. We have created our own Selenium Grid architecture by using the Docker containers, by using simple Docker commands. And let me create some sample test cases so that we will be able to run those test cases parallelly on these different nodes that we have created. So I will create few sample test cases, and that we will run in the next session. So this is the third session in the Selenium Grid Docker series, and in this third session we are going to see how we can run Selenium test cases in parallel mode on the Selenium Grid in the Docker. So we have set up our Selenium Grid in Docker in last session. So we have created the Docker containers for the Selenium Hub using this command, okay, and we have created the node containers for Chrome, Firefox, and Opera using these Docker commands. So we have published some port for external connectivity. So 4446 for Chrome, then 4447 for the Firefox, and for Opera we have published this 4448. So when we run our test case, we will be able to see what happening on that browser. Okay, so this is already done in the last session, and if you check on the browser, our all the containers are up and running. Okay, and same we can check with the Docker command, Docker ps, all the running services. So you will be able to see all these containers are created 6 or 7 minutes ago, and they are up and running. Okay, everything is here. And also in the Docker desktop application, we will be able to see all the status of the containers. Okay, so one more important point. So normally when our work is done for this all the containers and Dockers, we close this application, right? So once you close this application, whatever running services or whatever running containers are there, that will be taken down automatically. Okay, so all the running services will be taken down for desktop application. And if you want to use these containers, all these containers will be in an existed state. Okay, so all you have to do is you just have to start these containers. You don't require to create containers again. You just have to start it. Okay, so let me show you that. So I will just quit this Docker desktop. So you can do it from here. So Docker is stopped now, and if you check this grid console, you won't be able to see anything here because services are not running right now on this port number. Okay, so you can see this message. So now I'm going to start the Docker desktop application again. Okay, it is starting the Docker engine now. So within a few seconds it will be started. Okay, so now you can see in the containers, all these containers are taken down automatically and their status is exited. So all you have to do is you just have to start these containers again from this menu. Okay, so that we will be able to use these containers for running our Selenium test cases. So you can start these containers from this Docker desktop UI. Okay, just you have to click on the start button, and within a second it will be started. Okay, so this Selenium Hub is up and running. So if you check here the grid console, so now you can see that Selenium Hub is up and running. So now you just have to start the node containers as well. Okay, so you can start from here, and let me show you through the Docker commands also how you can start the containers. So starting or stopping any running container, it is very easy from this Docker desktop application, but you should know from the commands as well. So how to start the containers using Docker commands? First let's see what are the services are running. So sorry, it is Docker ps -a. Okay, so you can see only hub is running and all other containers services are down. So to start these containers, you just have to use this command docker start, and you just have to give the container ID. Okay, so if I want to start this container node chrome debug, so I have to give this container ID. So you can give only initials because this containers ID are unique one. Okay, so if I give F7 only, it will start this container. Okay, F7 is up and running now. So if I refresh here, so you can see that node running this Chrome browser is up. And if you want all the containers should start in a single command, so rather than starting one after another, you can use this command docker start. You dollar here in the bracket, you just have to use this docker ps -a -q and bracket close. So this command will bring all the running or all the services, and this command is going to start these services again. Okay, so whatever services which are running, it will be started, and the containers which are in exited state will be started. Okay, so you can use this single command. So if we hit the enter, so in the single command all the containers will be up. Okay, so this is starting one after another. So all containers are up now, Selenium Hub and other 4 node containers. So let me refresh the page. So yeah, so you can see that all the node containers are up and they are linked to this common hub at 4445. And same we can see in the Docker desktop. Okay, all are in running state now. So now coming back to our point that we need to run our Selenium test cases in parallel mode on this Chrome browser, then Firefox, Opera. Okay, so test case execution should start simultaneously on all these browsers. So let me show you the test cases that we are going to run. So I have created 4 tests. Okay, so let me help you to understand that. So these are very simple. So we are going to use the test ng for running our test case, and I have created 4 @test methods. So first one is Google on Chrome test. So in this first test case, what we are going to do is we are going to go to this google.com, and using test ng assertion, we are going to assert the page title. So we will get the title using this get title, and this is the expected title value. Okay, so if these two matches, then our test case will pass, and if it doesn't matches, then it will show you the this message in the console, and our test case will be failed. Okay, so this is very simple test case, and before closing browser, just we need to see in the VNC if it is working working fine or not. I have given the thread.sleep of 8 seconds. So you need to add this code in the try and catch block, so that exception will be cached in this, and that exception we will be able to see in the console. Okay, so in this second test case, we will go to this linkedin.com, and then again we are going to assert the title of the page. Okay, and in third test case, we are going to perform the same action, only we will go to the gmail.com, and then we will assert the title. Okay, and last test case, we have the Facebook, and there also we are going to do the same. For demonstration purpose, I have just created this sample very simple test case. Okay, so I have this 4 @test method, and I have one @before test method. Okay, so whatever code available in this @before test method is going to execute first before it start the execution of @test method. So before each and every @test method, this code is going to execute. So this is just in setup method, and here I am going to check what browser I want to run the test case, right? So before we open any page, we need to open the browser. So in the setup method only, I am going to decide that. So how you are going to decide in this setup method that what is the browser and which browser I need to open? Okay, how you are going to send the values to this method? So for that purpose, you just have to use this @parameters annotation from the test ng. So this value we are going to send from the testng.xml file. So that value I will send from the testng.xml, it will be cached here, and same value will be given to this setup method here, browser type. So if I send Chrome from the testng.xml, that will be cached here, and then we just have to check the browser type now. If this browser type equal to Chrome, that means I need to run my test case on the Chrome. So I will set the capabilities as capabilities.setBrowser type.chrome. Okay, so using this capability, Selenium Grid will come to understand that this test case has to be run on the Chrome. So it will forward that request to the Chrome node. Okay, so whatever node available at that time, which is running the Chrome browser, it will send this test case request to that particular node. Okay, so this is for the Chrome. So if I send the Firefox from the testng.xml, then that will be cached here. So that value will be compared in this block. So it is false, then it will come here, browser type equal ignore Firefox. Okay, right? So then here we will set the capabilities for the Firefox browser. So you have to use the same here, browser type.firefox. And for Opera, it will not execute this first two blocks. It will execute this final else block. So capabilities.set browser name, browser type.opera blink. Okay, so this is the capability for the Opera. And after setting the browser capability, we are just printing the statement that test case execution started on, and here we are going to print the browser type. Means if test case execution is started on the Chrome, it will show you that test case execution started on the Chrome. For Firefox, it will show test case execution started on the Firefox. So from console itself, we will be able to understand our test case is running on what browser. Okay. So this is for the @before test method. So before we start our test case execution, we need to open the browser, and first we need to check which browser we need to open. So that's why we have to add this code in the @before test method. So once our browser is confirmed in this setup method, then this @test case method's execution will be started. So all these test cases will be executed, and once test case execution is done, I have used this @after test annotation from the test ng, and here we are just going to print that test case execution ended. So once our test case execution is done, we just have to close that browser. So I have added this .quit in the after test annotation, because it is going to run after each and every test case execution. So now let's understand that which test case I am going to run on what browser. How I am going to decide it, that this Google on Chrome test should run on Chrome browser, then second test case should run on Firefox, or third test case on the Opera. How I am going to do that? So all this configuration, all this setting you can do through the testng.xml file. Okay, so let me show you the testng.xml now. So in this testng.xml, I have created 4 tests. So this is the test 1, then I have test number 2, then I have test 3, and then test 4. So we have these 4 tests in this testng.xml file that we want to run. And in each test, I have used this parameter, the browser parameter. Okay, so how you are going to use this parameter? You just have to use the parameter name. So that is the browser, and what should be its value? You just have to pass from here. Okay, so this parameter name we have used in the @before test. Okay, just I have shown you that this before test method is going to use this parameter. So whatever value I am going to send from here for this parameter will be cached here, and that same value will be cached in this setup method. Okay, so this is how you can send any parameter, any value from the testng.xml to the testng methods in the test case. So we have sent the browser we want to open. Now we need to decide which test case you want to run on this Chrome browser. So that you need to give from this class. Okay, so classes, then class. So class I'm going to run is the test dot docker selenium grid test. So this is my class name, and from this class I want to run this test method. So all you have to do is add this method stack, and inside methods you need to use this include name equal to and name of the method you want to run. So this is the method name Google on Chrome test. Okay, so this test case I want to run. Okay, Google on Chrome test. So as a part of this test 1, I want to run this Google on Chrome test on the Chrome browser. Then for second test, I want to run on that Firefox browser, and which test case I want to run as a part of this test 2, that is LinkedIn on Firefox test. Okay, so that means second test case I want to run on the Firefox. And in the same way you can configure for the other test. For test 3 we will open the Opera, and this test case should be run on Opera. And for the last test, test 4, again we will open the Chrome browser, and this test case should run on that Chrome browser. Facebook on Chrome test. Okay, so you can see that we have 4 nodes. We have 2 Chrome nodes and 1 Firefox and 1 Opera. So we can run all these 4 test cases simultaneously now. We have 4 nodes and we can run this in parallel. So how we are going to run this in parallel? So until now we have decided that which browser should open and which test case we want to run on that particular browser. Okay, using this test and methods and parameter stack. So now we need to decide how we are going to run this test in parallel. Okay, so that configuration you can do at the suite level. So what is suite in TestNG? Suite is just an collection of the multiple tests. So we have 4 tests here, right? So this suite will represent this collection of these 4 tests. So you can provide the suite name here. We can say like grid suite. So this grid suite have 4 test cases to run, right? We have 4 test cases to run. So now how to decide this, how we are going to run these 4 test cases? We can run in the sequential manner, one after another, or you can run in the parallel mode also. Or you can run 2 test cases at a time, then again 2 are done, again 2 test cases next time, like that. So that can be decided using this parallel value. Okay, so for this parallel, it is going to help you how you are going to run these test cases. If you want to run in sequential manner, you can give here methods. Okay, so all the methods will be run one after another. Or if you want to run all these test cases in parallel, just set this value to test. So by doing this, we are telling TestNG that whatever test cases available in this grid suite, I want to run all those test cases in parallel. So please run in parallel mode. So if you have the node available for Chrome, Firefox, Opera, please run the test case in parallel. And next thing is thread.count. So if you want to run the parallel mode, you just have to increase this count. So all the 4 test cases will be executed in parallel on these different browsers. So until now we have decided about the browser, which test case we want to run on that particular browser, and the parallel mode also. But I want to run this test case on the Selenium Grid running at 4445, not on my local machine, right? I want to run it on the Docker Selenium Grid that we have configured. So I want to run on this browsers, on the Docker containers. So to run our Selenium test case on the Selenium Grid in these Docker containers, we just have to point our test case to the Selenium hub. Okay, so we just have to give our test case to the Selenium hub, and then hub will decide whatever node is available depending upon the browser type. It is going to run our test case on that particular node running that particular browser. Okay, so first important thing is we need to point our test case to the Selenium hub running at this 4445. So how we are going to do that? So same you need to do in the before test, right? So before opening any browser, we need to decide where we want to run our test case. So we want to run our test case on a remote driver, right? Not on the local driver, local Chrome driver or Firefox driver. So it should be a remote web driver. So for that purpose, once our browser type is decided, okay, so I want to run on the Chrome. Then at the end, what we are going to do is we are going to create the web driver reference. So driver equal to new remote web driver. So we need to use this remote web driver class. And in the bracket, you just have to give the URL. New URL object, http:/localhost 4445 wd hub. So that means our Selenium Grid is running on the local machine at 4445. So this is the URL you need to give. Localhost 4445 wd hub. So in case if you are running on some remote machine using Amazon instance or any remote machine, you just have to give the IP of that machine and then append this wd and hub at the end. So by doing this, we are just forwarding our Selenium test case to this Selenium Grid or Selenium hub running at this 4445. Okay, and next parameter you need to give in this remote web driver is capabilities. Okay, so we have set the capability for the browser type, so you need to provide that as an argument. And depending upon this capability type, means browser type, Selenium hub is going to decide that which node I want to send this or forward the Selenium test case request to. So if browser is Chrome, it will forward the request to the Chrome. Then if it is Firefox, it will forward the request to the node running the Firefox browser, and for Opera, it will send for the Opera node. Okay, so I hope this is clear. So everything is done now. I hope you have understood how we have created the test case and how we have done the configuration. So just keep in mind, if you want to run your Selenium test case on the different browsers, right? So usually we run our test case on the different browsers. So same application we want to run on the Firefox, Mozilla, Opera, Safari, right? It is a common scenario. So for that purpose, you need to use the parameterization. So we are using this @parameters annotation. That means we are doing the parameterization through the XML file. So this is just one way how we can do the parameterization. There are different ways by which we can do the parameterization. So we can run our test case using the different parameters, using the let's say data provider is there, then we can run through the maven also. So for those I will create a separate sessions how we can run using the data provider or running a test case in parallel mode on this Docker Selenium Grid using the maven. So I will create a separate session on that. So as of now we are sending this parameter using the test.ng XML file, and using this parameter value we are going to decide the browser type. Okay, this is the browser capability, and depending upon the browser type, Selenium Hub is going to decide which node he need to forward that Selenium request. Okay, so let me open the VNC viewer as well to monitor the test case execution. Okay, so last session we have already connected to this Selenium Grid node with this VNC, so you just have to open it again. So this is the 4446, that means this is our Chrome node. At 4447 we have Firefox, and for this is the another Chrome node. Okay, so let's go and start our execution. So as we are going to use this parallel equal to test, our test case are going to run in parallel mode. So just right click on that, run as test.ng suite. Okay, so you can see all these test cases are running. This is the Firefox, this is the second Chrome node, and this is the first Chrome node. So all this execution are starting in parallel mode, and we are able to monitor it using this VNC viewer. Even you can interact with these browsers also. Okay, so I can click here, or I can close the browser manually, so I can manually interact with it also. So that is the use of VNC viewer. Okay, so all test case execution is done. So just only we do not have the Opera debug mode, that's why we could not see in the VNC viewer, but you can see that test case execution started on Firefox, Opera, the Chrome and second Chrome simultaneously. Okay, so execution started simultaneously, and once it is done, it has ended. That means our test case has passed, all the titles are correct, right? So what we are asserting is just an title of the page. So all the titles are correct, and that's why we got the pass result. And same you can see in the result of the test.ng suite. Here also you will see all the test cases are executed. So let us run one more time. This time we will see from the grid console. So once test case execution started, all these nodes will be in a busy state. Okay, so after refresh you can see this is in running some session, right? So some test cases are running. So if you send some more test case to these nodes, this test case request is going to wait for test case execution to be completed on these particular nodes. Okay, so once test case execution is done on these nodes, then this next test case execution will start. So our test case is running on Opera also, you can see that. So I think, okay, so all are free now. So all the nodes are free now, and if you check the result, all are passed. So this is how you can use the test.ng XML file for configuring all these test cases and running all these test cases in a parallel mode. Okay, using this parallel property and this thread count equal to 4. So let me show you how the test case will be executed in sequential manner. So for that purpose, you just have to set this parallel equal to methods. So if you run, first it will execute this Chrome test on the Chrome browser, then on the Firefox, then Opera will start, and then second Chrome test. So let's go and see that as well. And once test case execution started, only one test case is running at a time. So it has opened the Chrome browser. So next test case has to wait until this test completed. So Firefox will start now, and this is the second Chrome node. So after Firefox it will run the Opera test case, and after that this test case will run the last test case 4 on this Chrome second node. Okay, so Firefox test case execution is done. Now Opera will be completed, and then this Chrome will start. Okay, so you can see that this is the test case number 4, facebook.com. So this is how you can run the test case in sequential manner. Just set parallel equal to methods, and for running test case in parallel, you just have to set this parallel equal to tests. So another scenario can be, what if I want to run the same task on the different browsers simultaneously? That means I want to perform login scenario on the Chrome, Mozilla and Opera simultaneously, right? That is the normal scenario. So for that purpose, you just have to do some changes here. So for Chrome, we are running this Google on Chrome test. That is correct. For Firefox also, I am going to set the method name equal to this Google on Chrome test. And for Opera browser also, we are going to run the same test case. So by doing this, what will happen? Test engine will see, okay, this is the test method I want to run. So on the Chrome it will run the same test case, on the Firefox also same method, and for Opera also the same method. And we have set this parallel equal to test. That means all three browsers will execute this test, Google on Chrome test simultaneously. Okay, so let's see this scenario also. I will just we just don't want to run this test now. Okay. So at 4446 we have Node running Chrome browser, and at 4447 we have the Firefox. So both the test has started simultaneously. You can see that. So this is the google.com, and some issues there on the Chrome. Okay, so you can see both the test case are running in parallel on Chrome, Firefox, and here you can see I guess Opera is also busy. Okay, so this is how you can run the same method, same test case on the multiple browsers simultaneously in parallel mode. So you just have to configure the same method name in each and every test case. Okay, so very simple. So in this session number 4 in the Selenium Grid with Docker series, we are going to see how we can set up the Selenium Grid with Docker using Windows batch file. Okay, so in last session we have run our Selenium test cases in parallel mode on the Selenium Grid that we created in the second session in the Docker. So for creating Selenium Grid in the Docker, basically we just have to create the containers for each and every component of the Selenium Grid. So for Selenium Hub, we need to create a separate container, and for different browser nodes, we created the separate containers. Okay, so for creating these Docker containers, we just ran these few simple Docker commands. So there can be a problem that where when you type this command in the PowerShell, there can be a problem that you miss any important part, or you did some spelling mistake while writing the command. Okay, so this can happen when you are running multiple Docker commands. Okay, one after another. So instead of that, what we will do, there is another way by which you can run these Docker commands through the Windows batch file. So what we will do, we will add all these Docker commands in the Windows batch file, and then we will run this batch file for creating this Docker containers. Okay, so let me show you that. So what we have to do is just create a new text file here and just add all the commands in this file. So first step is we need to create the network, right? So you just have to write this command here, and then we need to create and run the container for this Selenium Hub. So this is the command, the next command. And then once Selenium Hub is ready, we just have to create the node containers for Chrome, Firefox and Opera. So just copy this Docker commands and paste in this text file. Okay, so we are going to run these 6 commands. So here we don't require to write the pull commands for the Selenium Hub image and Chrome node image, all these. Okay, so we are directly writing this Docker run command. So basically Docker is going to check if this image is available locally or not. If that image is not available locally, then it is going to download that corresponding image from the Docker Hub. Okay, so you don't need to write the separate command for pulling the images. So we will create the Docker network, and then we will create the Docker container for the Selenium Hub, and then we will create and link the Docker containers for the node browsers to this common Selenium Hub, and we are publishing the same port as that of second session. Okay, so all that I have done is only copied this Docker command that we ran in the second session for creating the Selenium Grid in the Docker. Okay, so we run this command one after another in that session, but here we have just added all those commands that we need to run in the this text file, and you have to save this file as a .bat. So while saving this file, you can save it any folder, and you can give any name here. Let's say create Selenium Grid. Okay, so this is my file name, and extension you need to add as BAT. Okay, and select here all files. BAT means Windows batch file, and save that file. So now all I have to do is we just have to run that batch file. Okay, so go to that folder where you have saved this batch file, that is in my Docker folder. So this is the batch file we created. So you just have to run this batch file. So just open command prompt from this location. Okay, and you just have to type the file name here. Okay, so we are going to run this Selenium create Selenium Grid batch file. So if you hit enter, all the Docker commands will be run one after another. So first it will create the Docker network. Then inside that network we have created the container for Selenium Hub, and all these are the node containers for the browsers. Okay, so you can see that all these Docker commands ran one after another in sequential manner. So by doing this, you don't require to write these commands manually every time run from the PowerShell. Okay, so just collect all the commands you want to run and add those in the text file and save that file as a Windows batch file. Okay, and then with the help of command prompt, you can run that batch file. So within a few seconds, our Selenium Grid architecture is ready on the Docker. So all the containers have been created and they are up and running. So that you can verify using this Docker ps-a. So you can see all these 5 Docker containers, the Selenium Hub and this node containers for the browsers are up and running. So from the browser, if you see our Selenium Hub is up and running, and these are the 4 nodes connected to that common hub. Okay, so you can directly run your test case from the Eclipse now using this test-ng. So if you are watching this session directly, I will suggest go and watch previous 2 sessions. You will understand how we created this configuration, Selenium Grid configuration, and how we designed this test case to run in parallel. Okay, so you just have to use this test-ng XML file, and if you run this file, all the 4 test cases, means in this XML I have 4 test cases. So all these 4 test cases are going to run on different browsers, Chrome, Firefox, Opera, and another container running the Chrome browser simultaneously. Okay, so let's quickly run this and we will check from the browser. So currently our nodes are free, but as soon as the test will start, they will be busy. So all 4 nodes are busy now. So you can mouse around that and can check that session is executing. So once test case execution is done, all these 4 nodes are ready to accept the another test case execution request from the Selenium Hub. Hello guys, welcome to the next session in Selenium Grid with Docker series. So this is session number 5, and in this session we are going to see how we can set up Selenium Grid using the Docker Compose file. Okay, so in second session we have already created our Selenium Grid architecture by running some Docker commands. Okay, so in that session we run this command for creating hub container, then we run a few more Docker commands for creating these node containers, and these node containers nothing but the browsers will link with the hub container. Okay, Selenium hub container. So there can be some issue or problem you may face while creating the containers or Selenium Grid architecture with this approach. So this approach means you need to write these Docker commands in the PowerShell or command prompt, and you need to run this command to create and start the containers for different components of the Selenium Grid, right? So in this, first important thing is you need to remember all these commands, right? For creating network, you need to remember this command. For creating container for hub, you need to remember this command for syntax and everything, right? So first challenge in this approach is to remember all the Docker commands for creating the containers. And another thing is it is going to take more time for creating and running these containers, right? Because first we create the network, then we create the container for hub, then we write these commands for creating the containers for the different browsers, right? Then again it is going to take the time. Because here in this we need to write these commands one by one in the PowerShell, and then we need to run it, right? And if you do some typo mistake or spelling mistake while writing this command, again you need to fix it, and again you need to run that command. So this process is going to take more time, right? And it is not limited to this only. In real-time projects we work in a team, right? So in team there are multiple members working on the same project. Let's say 10-15 people are working, so all these people will also have to remember all these commands for creating this architecture or any container. So again there can be an issue if they do some spelling mistake or typo mistake. Again it is going to take the time. And one more thing is, if any new member join your company or join your team, and probably if they don't know about this command, Docker commands or concept, then you need to provide this command to that member again. You need to explain them how you can run this and how containers are creating and all those things. So this process is bitterly time consuming. And if you remember, when we create the container for the nodes, we created the container for Chrome, let's say. And if I want to create another container running the Chrome browser, again I have to run this command. Okay, you can provide any container name and you need to run that command again. Means for each and every container you need to run separate commands. So if I run this command, I get the first container running Chrome browser. For another next container, if I want, again I have to run the command and I will get the another container running the Chrome browser. So likewise, you need to run this Docker commands again and again. Every time you require a separate Docker container. So by running a single Docker command, we cannot create multiple containers out of the same Docker image. Each Docker command can only create one container at a time. That means you need to run this Docker commands multiple times, right? Not only you, all the team members, if they require these containers, they will require to run these commands again and again. So to overcome all these problems, we use the Docker Compose file to create, run any container or starting any service or scaling the containers, right? So we can provide how many containers we want. So according to our command, it will create that much containers at a time. So the best way that we can do is to use the Docker Compose file for creating and running these containers. So here what I will do is I will create this Docker Compose YML file. So YML stands for yet another markup language. So if you know about test.ng XML, pom.xml, these are the XML language. So similar to these XML files, we can use these YML files to store and transport the data easily. And whatever data or whatever statement you write in this file are equally understandable to human and equally understandable to machine. Okay, so it is very easy to write and easy to understand. So here I created this Docker Compose file, Docker Compose.yml. So in this file, I will mention what are the different services I want, what are the different containers I want. For example, I will write that I want to create this Selenium Hub service. Then I can mention for creating this Selenium Hub container, what Docker image it should use. Then after creating the image, I can mention the ports also, what are the ports we need to publish, right? I can give the volumes also for the memory purpose, right? I can provide everything, like every environment that I want to use for creating this container. Okay, so you don't need to remember this command and run this command. Just in this Docker Compose YML file, provide the list of services or list of containers you want to create, and provide the Docker image name in that file from which this containers will be created. So this statement I written for the for creating the hub container. right? Selenium hub container. So same kind of statement I can write for creating these node containers also. Here also just have to mention the service I want to create, the service name, then Docker image from which this container should be created. So while creating this container, what ports it should publish, then I can mention about the volumes also. So whatever configuration you require for creating these multiple containers, you just have to mention in this Docker Compose YAML file. So as per your need, just provide different configuration like what Docker image you are going to use, what different ports you are going to publish, what are the different volumes, what are the different environments. So all I have to do is just create this Docker Compose YAML file, provide all the configuration, and once it is done, so we will provide this Docker Compose file to all team members, and they just have to run this Docker Compose file. Okay, so they don't require to remember all this command, they just have to remember single command for running this Docker Compose YAML file. So all of us, we just have to remember this command for running this Docker Compose YAML file, Docker Compose up. Okay, that's it. So as you can see, this command is very much easy to remember as compared to this command. So here you need to remember this lengthy command for creating the separate containers, right? So once our file is ready, Docker Compose is ready, we will share with all the team members, and using this command, Docker Compose up, we will run this file. So when you run this file, Docker will see what are the different containers you need to create, what are the different images the user have mentioned, and from that images it will create the container. And as per the port entry, volume entry, what are the different environments the user has written in this Docker Compose, it will provide that environment and that configuration to that particular Docker container. So within a very short period of time, all our containers will be created and ready to use. And as I already said, another great advantage we get with this Docker Compose YAML file is we can do the container scaling. So while running this Docker Compose file itself, I can do the scaling of the containers. So I will provide, while creating the containers for Chrome browser, please create 3 containers for the Chrome. Then I can provide, please create 2 containers for the Firefox, like that. So creating these multiple containers from the same images at the same time will be taken care by the Docker Compose file. And another point here is you don't require to create the Docker network on your own. So here while creating and running containers through the Docker commands, we need to create the Docker network first, and we need to make sure these containers are running in the same network so that we can link them and they can work together. But in case of Docker Compose file, we don't require to create the network. So here what it happens is whatever services and containers are created as a part of this Docker Compose YAML file will be created in the same network only. That will be taken care by this Docker Compose. So it will create a Docker default network. So all these containers will be created and run in the same default Docker network. Okay, so you don't have to worry about this network thing also. So this is also another advantage of this using this Docker Compose YAML file. And once your work is done, you know required to take these containers down one by one. You just have to remember this command for that purpose, Docker Compose down. So both these commands you can see are very easy to remember. So to create and run the Docker containers using this Docker Compose file, just run this command, Docker Compose up, and once you are ready to take all these containers down, just use this Docker Compose down command. So now let's go and see how we can create this Docker Compose YAML file so that we will be able to create the same Selenium Grid architecture as that of the second session, but this time we are not going to run any of these Docker commands. So we will just create this Docker Compose YAML file and we will run this Docker Compose up command. So let's create that file now. So I hope both Notepad file and Visual Studio screen are visible to you. So first of all, let us create a new file here and save that file as Docker Compose, Docker dash Compose, and file type should be YAML. Okay, so you can save in any folder in your directory. Okay, so Docker Compose YAML. So you can save this file using different name as well. So if you created this file and save this file name as Docker dash Compose YAML, then you can use this command to run this file. So first one you can use Docker Compose up, or second one is Docker dash Compose up. Okay, and if you want to save this file with some another name, you can do that. For example, you save that file as setup selenium grid.yml. So if you want to run this Docker Compose YAML file, then you need to use this command, Docker Compose. Okay, it is same. Then you need to use this f flag. Okay, here you can provide the file name you want to run. So here you need to provide this file name, whatever you have given to the file, and this is the up command. So this command will create and start all the services, whatever we are going to add in this Docker Compose YAML file. Okay, so we will see both the examples. So for creating Selenium Grid in the Docker, we are going to create mainly 4 services through this Docker Compose YAML file. So first service will be for creating this hub container, the Selenium hub container, and then another 3 services we will create for this node browser containers. So one container will be for Chrome browser, then another one is for Firefox, and next one will be for Opera node. And as we already discussed, we don't need to create the network in case of Docker Compose YAML file. So Docker Compose will create its own default network, and all the services that we mention here will be created inside that network only. Okay, so let's start. So how do we add data in this Docker Compose YAML file is you just have to add data in form of key and value pair. So first key is version : and its value is 3. Okay, so in case of YAML file, you need to take care of indentation. Okay, so press enter after the version, and here you need to provide services key. Okay, so this is my second key. Press enter. Then after pressing enter, just press tab key once. So under this services, we are going to add all the services we want to create. Means we will mention all the 4 services for this hub and node containers. Okay, so once you press enter, press tab key once, and here we will add our name of the first service. So first service I need to create for this hub container. So let me give name as hub service, colon, enter. So again you need to provide one tab. So from this position, whatever configuration you need to add for this hub service will be added. Okay, so after pressing enter, just press one tab, and here we will provide what image it should use to create this hub service container. So for that, I will add this Selenium hub. Okay, so we need to use this image for creating this Selenium hub container. Enter. So next thing is we need to provide the container name, right? So same here we need to provide. Only here we need to use this container keyword, container underscore name, colon, space, and I will provide name, the same name I will give. Okay, and next thing we want to publish the ports as well, right? So for that you need to provide ports. So this key will accept the list of entries, means list of data. So that's why you need to mention on next line, enter, and press tab key first, dash, and in double quote you can mention multiple entries here. So I will publish the same as that of second session. Okay, so what does this mean? It means whatever service that will run on port number 4444 inside this hub container will be mapped to the port number 4445 of the host machine, so that whatever service it is running inside this Docker container, I will be able to access from the host machine itself by using this 4445 port. Okay, so our first service entry is done. Hub service, image, container name, and ports. That's it. So now let us create services for our node containers. What I will do, I will just copy from here. We will just change the values. So this service name should be, let's say, Chrome service. So this is my Chrome service, and for creating the Chrome container, it should use this Docker image. So that I will mention here. And container name should be, here we have provided the Chrome node. Okay, so same I will do here. And ports we publish is 4446 with 5900. 4446 5900. Okay, so whatever VNC service running at this port number 5900 inside this Docker container will be accessed through this 4446 port number from the host machine, so that we will be able to connect to this port through the VNC viewer, and we will be able to see what exactly happening on the browser when we run our Selenium test case on the Selenium Grid. So after port, we need to add, means we need to link this Docker container to the hub container. Okay, so this is the node container, and we need to add it to the hub container, so that there will be a bidirectional flow between these two containers. So Selenium hub can forward whatever request, Selenium test case request coming, it will just forward to this Chrome node. So for that purpose, at this port level, you need to provide the environment, colon, enter. So press one tab key. So here we will add this hub host equal to Selenium hub. And here you can mention the hub port as well. So hub underscore ports equal to 4444. Okay, so hub port is 4444. And after the environment, another thing is this Chrome service is completely dependent upon this hub service. So if hub service is down, there is no need of creating this Chrome service because it is not of any use. So we are going to create dependency between these two services, means node services to the hub service. So how can you create it? You need to use this key, depends underscore on, colon, then provide tab key, hyphen, you need to provide this hub service name. So this is the service name on which this Chrome service is depend upon. Okay, so this is for creating this Chrome service container. Whatever configuration we are required, we have added this in form of key and value. So it looks very easy as compared to this lengthy command. You just have to add it only once. And using same configuration, we can create another Firefox and Opera node services. Okay, so you just have to change some values from this. And another point is here we have provided this container name for Chrome node, and under this port you can see we have specified a specific port. But when we are going to scale these containers using this Docker Compose file, we may face issues because we have provided the specific port. So if one container is already using this port, it won't be able to map same port to the 5900 for another container. So for now, let it be there, a container name and ports, and we will run this Docker Compose file without scaling. and once it is run, then we will scale the containers, and then we will see what error we will get, and accordingly we will make these changes. So let me copy this and add this service for Firefox and Opera. So I have added service for Firefox service and Opera service. So this two things is going to same for each service environment and depends upon. So this will be same, only we need to change the port we want to publish and the container name. Okay, so other things are same. And this is the node Firefox debug image will be used to create this container for this Firefox service. And for Opera service, it is going to create container out of this Selenium/node Opera image. So these images are already available on my local machines. So as compared to this Docker command, so you can see it is very easy to add these services inside this Docker Compose file. So just looking at the key name, you will be able to understand what exactly it is going to do. So this image means which image it is going to use, what ports we need to publish, what should be the container name. Okay, so it is very easy to understand. So once this file is ready, you just have to share this file with all your team members so that they don't require to remember all these commands and run this command again and again. Okay, so let's go and run this Docker Compose YAML file. So as we have saved this file as docker-compose YAML, we are going to use these two commands. So just go to the directory where you have created this file. So from here I will open PowerShell. Okay, so first let's see if any container or any service is running or not already. Docker ps. Okay, so there is no container, no service is running. So we need to use this command, docker compose up. Okay, so as we have saved our file as docker-compose.yml, you can use this command directly to run that file. So docker compose up, hit enter. So we are getting some error here. Additional property environment is, oh, we did the spelling mistake. So we need to make sure not to do any spelling mistake here. Environment. So copy this side here. So you need to make sure you are following proper indentation. The key name should be correct. Otherwise it will give error like this. Okay, so I hope others are correctly spelled. Okay, so let's go and run this again, docker compose up. So this time it is starting these containers. So you can see it has started network docker default first, and it is starting the different containers for different services now. So Opera node, Firefox node. So at the same time all these containers are getting created and started. So all these are the logs you can see. So the Opera node, this node is registered to the hub and ready to use. Okay, so Opera node is ready and it is already connected to the hub. Then the Chrome node is also registered, and somewhere we have Firefox as well. Okay, so from these logs you will be able to see what exactly happening when we run the docker compose up command. So you can easily cross verify this, the network is created or not. So for that let me open another window of PowerShell. Okay, so here I will check docker network ls. So these are the different networks already available and created in my Docker. So Docker default is, if it is there, yeah, you can see here we have this Docker default network. So this network is created by the Docker Compose, and whatever services we have created as a part of this Docker Compose are already linked to each other and they are available in the same network. So our hub is up and running and all these three containers are up and running. So we can verify that as well here. Let me docker ps. Okay, so you can see we have total 4 containers. So one container is for Selenium Hub, another one is Chrome node, then Opera node and Firefox node. And whatever entries we have provided for this ports part, they are correctly configured by this Docker Compose. So this 4447 port mapped with 5900, and this 4444 for Selenium Hub is mapped with 4445 of the host machine. Okay, so let us go and see if we are able to access this service on this port number 4445 from the browser. Okay, so if you open localhost 4445, you can see that Selenium Grid Hub 3.141.59. So this Selenium Hub is up and running here. And if you go to the console, you can see all these 3 nodes running Chrome browser, Firefox and Opera are connected to this common hub. Okay, so now we will be able to run our test case in parallel or in sequential manner as per your wish. And if we go to the Docker desktop application, there also you will be able to see this is the grid created, and inside this same we have 4 containers up and running. So same logs you will be able to see. Just click on that Docker and you will be able to see same logs here. And you can also check the logs for these individual containers as well. Okay, so this node is registered to the hub and ready to use like that. And you can even inspect as well. Okay, so you can see what is the hub host here, the Selenium Hub, what is the hub port that is mapped is 4444. Then we have published the port as well, so that entry also be available here. So here it is, port 5900 TCP is mapped with 4448. So now we have successfully run this Docker Compose YAML file. So all the services that we have mentioned in this Docker Compose YAML file, all these services got created and started by the Docker Compose with the whatever configuration we have provided. So for this, we just run a single command, Docker Compose up, and all our Selenium Grid architecture is ready within the few seconds. So now let us take these containers down. So press Ctrl C, it will stop these containers. So let us save that file as some different name. We will use some different name to that file, and let us try to run that file as well. So first let me remove all the containers. Docker Compose down. Okay, so all containers are taken down. You can see that there is no container running. That means all the services have been taken down. So let us save this file with some another name. So we have taken an example here. We will give this name to this file, seleniumgrid.yml. Let me rename this. Okay, so this is our file name now. And now if you try to run this Docker Compose file with these two commands, it is not going to work. Okay, so let us see that as well. So we will use this command, Docker Compose up. So you can see you can't find a suitable configuration file in this directory or parent. Means there is no file with the name docker -compose.yml. And another command is docker -compose up. So for this command as well, we got the error. So how we can run if we have given some any other name? So you just have to use this command. It's very easy to understand. Docker Compose. This is the file flag, and provide your file name here and then up command. So I think, let me check the file name. So here we don't need to give this .yml. Okay, let it be just set up Selenium Grid. And if you try now, okay, so now it is working. So this is how this Docker Compose works. It will works in step-by-step process. It will create the Docker default network, then create the services, and then link these services to the common hub according to the configuration we have provided in the Docker Compose YAML file. Right? Whatever port we have mentioned, it will publish those ports. So everything is done step by step. So all these services and containers will be up and running within few seconds. Okay, so it saves a lot of your time compared to running the Docker commands for creating these containers. Okay, so next thing only remaining is scaling up the containers while creating or running this Docker Compose up file. So let us see how to do that. But before that, let me show you how we can run this Selenium test cases on the grid that we have created. So we have 3 nodes now and 3 different browsers. So if we refresh this, so now we can run our Selenium test case on one test case on Chrome, one on Opera, and one on Firefox in parallel. So in session number 3, I think I have created few sample test cases. So let's try to run the same on this Selenium Grid created with the Docker Compose. So if you want to see how those test cases are created and how we configured it to run on different browsers in parallel, you need to see the session number 3 in this playlist. So you will find detailed information about that in that third session. We have added 4 different test cases in this test.ng XML file. Okay, so we will, as of now, we will run this 3. So one test case will run on the Chrome browser, the next one will run on Firefox, and another one is going to run on the Opera browser. And this is the class in which we have configured everything. So we have used before test annotation and parameterization using this test.ng XML. So we have provided the browser value from that test.ng XML, and according to the browser name, we have set the capability. So browser name, and same capability you need to provide to this driver equal to new remote web driver. Okay, so in this URL we have provided where our Selenium hub is running. So this is running at localhost 4445, right? We have exposed this port 4445 wd/hub, and need to provide another thing, capability, as argument as well. So now hub is going to decide if we get a capability as Chrome, it is going to open the Chrome browser and run your test case. If we get the capability related to the Firefox or Opera, so it will forward those requests to that particular node running that particular browsers. And these are the sample test cases I have created. Just opening the Google Chrome, and we will going to assert the titles. Then another test, we are going to open the LinkedIn and then check the title, and same for the another one, the Gmail. Okay, so all these 3 test cases are going to run on different browsers, Chrome, Firefox, and Opera in parallel. So for that we have provided this parallel equal to test as well, and thread count equal to 4. Okay, so you will find detailed information in the third session, so you can watch that. So as of now, I will just right click on that and run as test.ng suite. So test execution should start on these 3 browsers simultaneously. So you can see once test execution started, it will show you So execution started on Firefox, Opera, Chrome. So it should start the session now. Okay, so it has created the session, and you can see here all the nodes will be busy now. Okay, so all 3 nodes are busy now, means our test case is being executed on this particular browsers. Okay, so first execution is done. Okay, so Chrome is free now. They are still busy. Okay, so all 3 nodes are free now. So we will be able to run our another test case on these nodes now. So last thing we need to see is how we can scale the containers. That means, so currently we have created only one container for each browser. So you can see one container for Chrome, one container for Opera, and one for Firefox. But if I want to create multiple containers, that means if I want to create and start 3 nodes running the Chrome browser, so you should be able to see similar entries, 3 entries here, one after another. Okay, for the Chrome. And similarly, I can scale for other nodes also. So I can have multiple Chrome, multiple Firefox browser nodes, and multiple Opera nodes containers. So let us see how we can do that. So to scale containers, what we have to do is you need to use the same command. So we are going to use the same. Only at the end we are going to use this -- scale flag. Okay, then provide the service name you want to scale. So let's say I want to scale my Chrome service. So copy this name and add it here as Chrome service equal to how many Chrome service you want to create, means how many nodes you want to create and start this service. So let's say I want to create 3 nodes. Okay, so 3 nodes for the Chrome. So let's go and see if it works or not. So just copy this. So Docker compose -f selenium setup selenium grid.yml up, and here scale Chrome service equal to 3. So now, as I already mentioned previously, that we have provided this Chrome node to the container name. So while scaling, it is going to create multiple containers. So this container name should be unique one. So more than one container cannot have the same name. So that's why it has given the error. This container name Chrome node is already there. So that's why it is providing the warning also here that the Chrome service is using custom container name. Means custom name means user has provided the container name, not the Docker compose deciding. So Docker requires each container to have a unique name. So remove the custom name to scale the service. So if you want to scale the service, you need to remove this key. So let me remove this quickly. Okay, so let us rerun that command now. So it is going to create separate containers for separate service. So 3 services, 3 containers for the Chrome, and 1 container for Firefox, and 1 container for the Opera. So if you scroll up, you will be able to see these 3 different containers for the Chrome service 1, 2, and 3, and another containers for Opera and Firefox are linked with the same Selenium hub container. So now if you go to the browser, you will be able to see 3 nodes running Chrome browser. So you can see this is one, this is second container running Chrome, and this is the third container running Chrome browser. Okay, so what we have done here is just scale this Chrome containers. So while creating and starting containers from this Docker compose YAML file, we have used this scale flag, and we have provided which service we want to scale. So I want to scale this Chrome service, and you just have to provide the value. So very simple command for scaling purpose as well. So it is very easy to remember. Docker compose -f, the file name you want to run up, and this scale flag, and provide the service name and the count. Okay, so similarly, let us run for the Firefox and Opera. So let us see, this Opera service 2 is there, then Firefox service 2 also got created. So everything is happening very quickly, right? So it's very useful, this Docker compose file. And if you check the browser now, let us just refresh this, and you can see now we have Opera node 1, then this is the second Opera, 2 Operas are there, and 3 nodes running the Firefox. Okay, and 1 is there for Chrome browser. Okay, so this is how you can keep scaling these containers as per your need. So if you want more test case to be run on multiple browsers, specific Chrome or Firefox, just scale those containers while running your Docker compose file, and then you will be able to run all those test cases in parallel mode very easily. So let me just quickly see the details of this running containers. Docker ps-a. So here I just wanted to see what port it has published. So you can see Docker has itself published this port 57623 for this Chrome service 3. and for Firefox different services it has published this different port. So whatever port it is available at that time, it has published to the 5900 of the Docker container. And same if we go to the Docker desktop application, you can see here as well. So all containers are up and running now on the different ports. So when you create a Selenium Grid inside the Docker, we can create multiple instances for the nodes, and we can define or we can create multiple sessions for that particular node as well. So this will help you to run your Selenium test cases in parallel on multiple instances by creating the multiple sessions on the node containers. So I'm going to show you all these things practically. Okay, so for demonstration purpose, we are going to use the same Docker Compose YAML file that we created in the last session number 5. So in that fifth session, I have covered everything in detail. Okay, so we have provided the hub service, that is the Selenium Grid Selenium Hub. Then we have defined 3 services. One is for Chrome browser, then second container will be for Firefox, and third container will be for Opera. So let's go and run this Docker Compose YAML file to create our Selenium Grid. So first let's see the list of services which are currently running in my Docker. Docker ps-a. Okay, so there is no service, no container is running. So let's go and run this our Docker Compose YAML file. So to run our Docker Compose YAML file, you need to use this command docker compose -f, then provide the file name. So my file name is this .yml and up and -d. Okay, so -d is for detached mode. So all the process that is going to happen will happen in background. Okay, so within a few seconds our Selenium Grid will be ready. And now again, if we check the list of services, you can see we have these 4 containers. One is hub and 3 are the node containers. So we can see we have the Selenium hub container running at 4445. So we can access this service from the port number 4445 from the host machine, from the browser. So if you go to this localhost 4445, you can see the Selenium Grid hub service is running. And if you go to the grid console, you will be able to see 3 nodes running Opera, Chrome and Firefox browser. So currently we have only 1 node for each browser. So now if I want to create multiple nodes running this Chrome browser, for example, I will have to scale this Chrome service. So how I am going to do this is, you just have to use the same command for this purpose. Copy that command. So you will require to run the same command, only you need to use the scale flag for scaling the service. So now we are going to scale our Chrome service, right? So you need to copy this service name, scale Chrome service equal to how many nodes you want to create, let's say 3. So if you run this, it is going to create 3 nodes running Chrome browser. So now we will be able to see Chrome service 3, Chrome service 1 and 2. That means there will be 3 containers. And if you check the list now, you will be able to see we have more containers now. So we have total 5 containers now. 1 container for the Selenium hub, next one is for Firefox, then Opera, and we have 3 containers running this Chrome browser. And Docker Compose have published this random port, whatever are available at that time, to the 5900 of Docker container. And from browser, if we refresh now, you will be able to see that we have 3 nodes now running the Chrome browser, right? So now you will be able to run your parallel test case on these multiple Chrome browsers. Okay, so next thing we are going to see is defining this node max instances. So that means currently we are able to see only 1 instance in each node or each container, right? So we have only 1 instance of Chrome browser in each container, then 1 instance of the Firefox in this container. Okay, so we do not have the multiple instances. So what if I want to create multiple instances in the same container? That means I should be able to see multiple Chrome browsers in this container. So currently we have 1. So if I define 3, then it should show me 3 Chrome browsers in each container running the Chrome browser. Okay, so Chrome is running in 3 containers, and so in all 3 containers I should be able to see 3 Chrome browsers here. Okay, so how you are going to do that? Just have to use the Docker Compose YAML file for that purpose. So just go to Docker Compose YAML file, and you need to define 1 key under the environment. So that is node underscore max instances. So this key you need to define in the Docker Compose YAML file for that particular service. So for example, we are going to create multiple instances for this Chrome service. So what we will have to do is just go to this Chrome service, and under this environment key you need to add 1 more key here. So that is node underscore max instances equal to, let's say, 3. So we have scaled this Chrome service already equal to 3, and we have defined this node max instances equal to also 3. That means we are going to see 3 instances of the Chrome in each node container running this Chrome browser. So let me save this and we will use the same command now. Okay, so let it finish the process. Okay, everything is started now. So now if we refresh this browser, so now you can see that we have 3 instances of Chrome in each container running this Chrome browser. So currently we have 3 node containers running Chrome browser, and in each container we have these 3 instances of the Chrome browser. So next property is defining the maximum sessions. That means here we have created the maximum instances. So by using this node max sessions, we are going to define how many sessions should start in particular node. Okay, so by using this node max session, we can limit the number of or maximum number of session can be started at the same time for the particular node container. So how you are going to do that? We will have to do the same. Again, go to your Docker Compose YAML file, and you need to add this under the environment node max session. Okay, so let me go here. One more property here we are adding node underscore max underscore session equal to, let's say, 2. So we'll have to run our command again to get our changes reflected for the Selenium grid. Okay, so from Chrome browser, if you refresh, you won't be able to see from this tab browser, but if you go to the configuration, there you will find the maximum session value here. Okay, so maximum session is limited to 2, and under capabilities you will be able to see maximum instances. So maximum instances are equal to 3 and maximum sessions are equal to 2. Okay, so this information you will get from this configuration tab for every Chrome browser node container. So now let's go and run our Selenium test cases, multiple Selenium test cases in parallel. So we will see what will happen if we provided 3 Selenium test cases to the hub to run on the Chrome browser in parallel. Okay, so the test cases have already created in the previous session, in session 2. So I am going to run 3 tests on the same Chrome browser, so that we will be able to see the use of node max session and node max instances. Okay, so all these 3 tests are going to run on the Chrome browser only. Okay, so we have provided 3 test cases to be run to the Selenium hub. Now hub is going to decide, depending upon the capability, that it has to open the Chrome browser now. We will see which node will be activated first. So if you refresh the page, you can see 1 instance from this container and 1 instance from this, and 1 instance from this is started running our test case. Okay, so it has used 1 instance from the each node container. So now what we will do, we will remove this multiple node containers from the Chrome browser. We will keep only one running 3 instances of the Chrome browser, and then we will run our test case and let's see what will happen. So for that purpose, what I will have to do is I will have to scale this to 1. Okay, so now you can see we have only 1 node running our Chrome browser, and we have 3 instances of the Chrome browser in that node. So let's go and run our 3 test case again on 3 Chrome browser. So this time we need to verify it should not start all these 3 instances, because we have defined maximum instances equal to 2. So you can see only 2 instances are busy now. Even though one is free, it is going to wait for one of these instance will be free, and then next test case execution will start. Okay, so all are free now, and if we check the result, 3 run, 3 passes. Okay, no failures. That means all our 3 test cases has run on Chrome browser in parallel. So they started on the Chrome at the same time, but only 2 sessions started at the same time, because we have defined this maximum session equal to 2. So that is why one test has to wait, so that one of these instance will be free from the test execution. So once that test execution is done, the next test case will start executing. So this max session property you can use to limit the number of sessions started at the same time for the particular node. If that node has multiple instances of the same Chrome browser or Firefox, we can limit maximum sessions to be started at the same time by using this max session. Okay, so now let's quickly see if I make this max session equal to 3, whether this all 3 instances will start simultaneously or not. So we will just change the value from this Docker Compose. So we have 3 instances of the Chrome browser and we have set this max session equal to 3. So we need to run the command again. So it is going to recreate this container because we have made the changes for this service only and other two are already running. So there is no need to start it again. So first to verify from the browser. So if you refresh, let's go to the configuration and you can see here maximum session is set to 3 now. Again, maximum instances are 3. So let's quickly run our test case. So you can see all the 3 instances are busy now, right? Okay, so all 3 are free now. So all these 3 are very important in your real-time projects and in your interview point of view also. So don't forget to prepare this well before you go for the interview. You just have to remember this command for running our Docker Compose YAML file. How we can scale it by using the scale flag, provide the service name and the value. For these node max instances and node max session, you just have to make changes in the particular service in your Docker Compose YAML file. So under this environment, you need to add these 2 node max instances and node max session. And depending upon this value, this configuration, our test case will start executing on this Chrome service running container. So in this playlist, in previous 6 videos, we have configured a Selenium Grid 3 by using Docker commands, by using the Docker Compose also, and with the bash file. Okay, so we have seen all these things in detail in the previous session. So let me copy the Docker commands that we have used for configuring the Selenium Grid 3. So as you can see, we have used this command for creating the container for our Selenium Hub and different commands for creating the containers for the node browsers or the node containers. Okay, so let's try to write the Docker command for creating the Selenium Grid 4 now with reference to these commands. Okay. So first, let's write the Docker command for creating the container for Selenium Hub. Docker run -d means this process should run in background. Then -p. So here what we are doing is port mapping. Okay, so there is a separate video on port mapping, why it is required and how it is beneficial in case of Docker container and host machine. So you can watch that video also, available in the playlist. So here I am just going to map the same port, this one. So port number 4445 from the host machine is mapped with the 4444 from the Docker container. So next thing is we need to start this container in a network. So for that purpose, we will have to create network first. So for example, grid 4 network. Okay, so this is my network name. So we will create this network. So for creating network, command will be same for grid 3 and grid 4. So first of all, you need to create the network. Okay, so all the containers that are hub containers and your node containers should be in the same network so that they can communicate with each other, and that will create a bidirectional connection between Selenium Hub and node containers. Okay. So this command will be same. Docker create network and give your network name. So I am going to create network with this name. So this is grid 4 network. So for creating network, command is same for grid 3 and grid 4. So here we are using this network flag. This is the network name and then hyphen name. So what should be my container name? So I will use the same. Okay, so as you can see, we have almost same command as that of grid 3. So only difference here will be image. Okay, so here we have used the latest image from the Selenium/hub. So here we are going to use the separate image, that is the 4th version of the Selenium Hub. So Selenium Hub : and here we need to specify the tag. Okay, so let's give the tag. Okay, make sure you are giving the correct tag here, otherwise you will face the error. 4.0.0 dash RC dash 2 dash 2021 09 and 30. Okay, so this particular Selenium Hub image we are going to use for creating our Selenium Grid 4. Okay, so make sure you give the correct tag here. Okay, so according to this tag, our Docker will first check this image is available on your local machine or not. Okay, so if it is available locally, then it will use that image for creating the container out of that image, and it will create and start that container. If image is not available locally, then it will go to the Docker Hub and it will check if this image is available or not with this tag name. And if it is available, then it will pull that image. Okay, so that image will be available locally and then it will create the container out of it. Okay, so as you can see, Selenium Grid 3 command and Selenium Grid 4 command is almost same. Only we have changed our image name. So now let's write the Docker command for creating the node containers. So first let's create container for our Chrome browser. Docker run -d, run in background, then -p. Okay, so here I am going to specify the specific port that I want to publish. So here I am going to map the same port here, and we have created our hub container in this network. So we need to create our node containers for browsers in the same network. Okay. And next thing, we had specified the environment, that is hub host equal to Selenium hub. That means this container should be linked to this hub host, that is the Selenium hub container. So same we are going to do here, only a slight difference is there. So here we are not using this key here, hub host. Here instead of that key we need to use se underscore event underscore bus underscore host equal to your host name, that is the hub name. So this is my hub. Then next parameter, next environment, p se underscore event underscore bus underscore publish underscore port equal to 4442. Okay, so these parameters we are adding for creating the correct connection between our node containers and Selenium hub. Okay, so these ports are already exported in our Selenium hub container, so we are just using it. So next environment, se underscore event underscore bus underscore subscribe underscore port. So we need to subscribe to the port, and that port number is 4443. So these three keys we need to specify in our Docker command as an environment. Se event bus host, that is your hub name, then se event bus publish port 4442, and se event bus subscribe port 4443. Okay, so that is our environment is done, and then we need to give the container name. Okay, so you can give any name to your container. Chrome node 1. Okay, and here we need to specify the Docker image name from which this container should be created. Okay, so here you need to use this image selenium slash node Chrome, and here we will specify our tag. So our tag should be this one. Okay, so this we have used for the Selenium hub. The same we need to use for our node containers. Okay, so this is the complete command for creating our first node container running Chrome browser. So one more point in case of Selenium Grid 4 is we can access both VNC service and no VNC service. So VNC service means whatever service it is running at 5900 inside Docker container, we will be able to see using this port number 4446 using the VNC client. So in previous sessions we have used VNC viewer as a VNC client. So when we start our execution, Selenium test case execution on these node containers, we will be able to see how our test case are running on that particular browser, Chrome or Firefox, right? So that is for the VNC service, for which a VNC client is required. But here Selenium Grid 4 supports no VNC also. So no VNC means it do not require any VNC client such as a VNC viewer. You will be able to access that service from the host machine from the browser itself. So we will see both the example, our VNC service from VNC client, VNC viewer, and no VNC service from the browser itself. So one more point here, you can specify your host memory also. So whatever Docker containers you are going to create, these containers are going to use the memory from the host machine. Okay, that is the host shared memory. So for that purpose, we just need to use the SHM flag, so that we can specify here. Okay, before name SHM, right? So this flag is for sharing the host memory for the Docker containers, right? SHM dash size equal to. So here you can specify the size here. Let's say, and it should be double quote. Okay, so this is the complete command for creating our first Chrome node container from this image. So you can see 50% portion is very much similar to our Selenium Grid 3 Docker command. So here we have just mentioned some different keys here: se event bus host, se event bus publish port, and subscribe port. Okay, so this command should create our first container, and VNC service will access through this 4446. So let me copy this command, and in this command we will map a no VNC port so that we can access that no VNC service from the browser from the host machine. So only one change we will do here. Instead of mapping 5900, I am going to map 7900. So this is the default port for no VNC service. Okay, so inside our Docker container, when we create, the no VNC service will run at this port number. Okay, 7900. So if you want to access the same service from the host machine, then you need to map this port to the any other port. So 4446 will be already used by Docker container. So we need to use any other. So I will use here 4447. Okay, so by using this 4447 port number, we will be access this service from the host machine browser itself. Okay, so that we will see practically when we run our Selenium test case in parallel on this Selenium Grid 4. Okay, so it's time to run this command. So let's move to the PowerShell now. So as I already said, first we need to create the network and then we will create our hub and node containers. So for creating network, this command is a little wrong. It should be docker network create grid for network. Okay. So use this command for creating the network. Okay, our network is ready. So let's get our Selenium hub container ready. Okay. Next one will be the container for our first node Chrome browser. Okay, and the next one will be the container running Chrome browser only, but we have exposed this NoVNC client, okay, for accessing NoVNC service from the host machine browser itself. So here we just have to change our container name. It should be Chrome node 2. Okay, so as two containers cannot have the same name at the same time. So let's check the list now. Okay, so we have 3 containers up and running on different ports. Okay, so let's try to access this Selenium hub service on port number 4445 from the host machine. So if you go to your browser on localhost :4445, you will see that Selenium Grid 4 is up and running here. So you can see as compared to Selenium 3, we have a very good look and feel UI here. So you can see here we have 2 node containers running Chrome browser, okay, linked with our Selenium hub. And in this session tab, you will be able to see whatever session that are running or whatever the session that are in the queue. So we'll understand this when we run our test case in parallel. So first let's go and create 2 more containers. One will be for Firefox and another one for the Microsoft Edge browser. So for that purpose, copy these commands and paste. Just have to change the port 4448 and I will just change my node here. So this should be Firefox node 1, should be 2, right? And the image we are going to use is node dash. Just change the name here. So now I do not have this node Firefox 4th version image on my local. So it will go to the Docker hub and it will pull that image. And for this Chrome node and Selenium hub, these images are already there on my local. So these containers got created immediately. So in your case, when images are not available locally, it will take some time depending upon the image size and your network speed. So if I hit enter, it will show that unable to find this image locally and another. I think I got disconnected from my internet connection. So we need to make sure we are connected to the network while running the Docker command so that it can download these images from the remote Docker hub. So let me rerun the same command now. Okay, so it could not find this image locally, so it will go and check on the Docker hub with this tag 4.0.0, and this is the image Selenium / node Firefox. So let's see. It will take some time. So what I will do, I will just pause the video until it get completed. Okay, so we have created 2 more containers. One is for this node Firefox and another one is for the Selenium node Edge. And on the browser, you will see 2 Chromes, 1 Firefox and 1 is Microsoft Edge. So first, let's try to access the NoVNC service for these containers. So first, let's check the list. So VNC service will be accessible at these ports 4447, 4448 and 4449 for these respective browsers. You just have to add this localhost 4447, 4448 and 4449. Okay, so this is a NoVNC service. So just click on this connect and this password will be secret. Let me edit for all. Okay, so this is the NoVNC service running inside the Docker container, and that we are accessing from the host machine using the different ports. And same, if you want to verify inside the Docker container, just run this command docker exec -it, give the container ID you want to go inside. So let's go to the Chrome container 2. It's 22. Okay, I forgot the bin bash here. Okay, so we are inside the container now. You can see cell user @ this is the container ID. So now if you want to see what is happening on the port number 7900 inside this Docker container, you just have to call this local host 7900. So in response, you will see we have got this the content of the HTML page. Actually, this is the body. So this is just an content of the HTML page for the no VNC service. Okay, title no VNC. So let's get exit from this container now. You can even check the Docker logs for this container, or you can inspect as well. So we will see more details in this. So whatever the port you have published, 7900 TCP port is mapped with the host port 4447. Okay, and here you will find this SE event bus subscribe port 4443, the host name Selenium Hub, and SE event bus publish port is equal to 4442. Okay, so you can easily check the Docker log, or you can inspect the containers also. And if you want to check the memory or CPU utilization, you can check using this command docker stats. So if you run that command, you will see whatever the containers are up and running and their name, what is the CPU utilization, memory utilization, all these details. So currently we are not running any test case, that's why this utilization is low. It is around 5 to 10. So let's go and run our Selenium test cases in parallel on these containers now. So for demonstration purpose, I am going to use the same project that we created in the session number 2. So please watch session number 2 to understand how we have designed these test cases, how we have configured these to run our test cases in parallel on different browsers. So we will go and run our test case on the Chrome, then Firefox, and instead of Opera this time, I will use the Edge. Okay, and we will run our test case on the Edge browser. Let's say this is our Edge test. Okay, so just go to your test.xml, parallel equal to test is already set, and thread count is 4. So first test should be run on Chrome browser. Okay, then second test should run on Firefox, and let's run this third one on the Edge, and the last one also we can give on any browser. Let's keep it on the Chrome. So now all we have to do is to point our test case to the Selenium Grid running at this 4445, right? So that you can do on this Docker Selenium Grid test class and @ before test method. So that is already set. Here driver equal to new remote web driver, and this is the URL you need to give, http:/localhost 4445 WD hub. So in case of Selenium 3 Grid 3 we are giving this WD hub, but in case of Grid 4 we don't require to give it. Okay, so there won't be any issue if we provide a WD hub, but it is not mandatory to give for this Grid 4. So let me remove this. So let's run this test.xml as test.ng suite. Okay, so you will be able to see test case here. It is for Mozilla Firefox, and this container is for Microsoft Edge. Okay, so this is the session which is running. Okay, so all are done now. So our 4 test cases got executed in parallel on this Selenium Grid 4, and all 4 got passed. Okay, so let me rerun this one more time to show you this memory status. So you can see this is normal now. So once we run it, it will increase the utilization for the memory and CPU. So now let's check. So you can see 95, 76, and it is utilizing the more memory also. Okay, and we can run our test case serially as well. So just set these two classes. So at a time only one test case will start executing. So currently it is executing on this Chrome browser. So we have here in queue we have 1. So these values are getting changed as and when test case execution is starting on the different browsers. So we have total 4, 1 is executing, so concurrency is 25%. So another one for the Microsoft Edge has started now, and this should be the last one now. You can see here the capability set for this particular browser. Okay, so all tests got executed now and no sessions are running now. Okay, cool. And if you want to access this VNC service through the VNC client on 4446, just download and install VNC Viewer application and open that application and just add IP here 127.0.0.1 colon and the port number. So we have given this 4446 for this Chrome node 1 container 446. Okay, so it will also ask you for the password. So here also we need to enter secret in lowercase. Okay, so this is the Linux container running our first Chrome browser. Okay, so we can monitor our test case through this VNC service, or you can use this no VNC service as well. So instead of running these commands one by one, we can use this Docker Compose YAML file. Okay, so it's a configuration file where you can mention what are the different services you want, and with the help of single Docker command, this Selenium Grid 4 will be up and ready for use. Okay, so what happened with this case? So when you are running these Docker commands one by one, first thing is you need to remember all these commands by your own, or you are working in the team, right, in real-time projects. So all the team members will have to remember these commands, and they need to run these commands one by one. So this process is going to take the time, and we are the humans, we do the spelling mistake, right? So due to that also you will face the errors, you need to fix it and again run that command. So instead of this approach, I will show you how you can create and configure this Docker Compose YAML file, so that we will get the same Selenium Grid 4 architecture in the Docker that we got in the previous session by running these Docker commands. Okay, so for reference purpose, we will use these Docker commands and the Docker Compose YAML file that we used for creating the Grid 3 in the previous session, so that we have created in the session number 5, right? Okay, so I have explained in detail everything about how we can create the Docker Compose YAML file, what are the things you need to remember while adding the services in the Docker Compose YAML file. Okay, so this is the Docker Compose YAML file that we use for creating the Selenium Grid 3. So we will use this file. So let me make a copy of this file first. Set up Selenium Grid 4, we will say, and extension should be YAML. Okay. Okay, so we will make change in this. So let's give the version as 4 services. So in case of this YAML file, you need to take care of indentation and spaces. Okay, if you miss any space or if you do any extra space, that will create an error. So you need to make sure you follow a proper indentation and proper spacing while adding these services. So under this service, we are going to add all the services that we want. So we want Hub service, we want Chrome service, Edge service, and Firefox service. So first service is Hub service. So for creating our Selenium Hub, we need to use the different image. So for Selenium Grid 4, we have used this image, right? So we will add this, and then this container name, let it be Selenium Hub. Then ports we want to publish. So here I will publish 2 more ports. So for creating a link between our Selenium Hub and node containers, we need different ports, right? So here I'm going to publish 4442 and 4442 from the Docker container. And next thing which we need to subscribe, right? So this is 4443 4443 from the Docker container. Okay, so this port is the key, and this key will accept the array of values. Okay, so that's why we have added it on the separate lines. Okay, so for this key you can see I have added on the same line. Okay, because it is accepting only single value, but this key, port key, accept the multiple values. That's why you need to add it on the separate line. The next service is Chrome service. So this shouldn't be here, should be after the environment. So for this creating this Chrome service, we will require a different image for Selenium Grid 4. So this is the image that we need to use for creating node container running Chrome browser, right? So this is my image name. And next thing we need to add is for sharing the host memory for these Docker containers, we need to add this SHM flag, SHM underscore size colon, and let's give as 2 GB. Okay, so now we need to publish some ports. So 5900 is for VNC service and 7900 is for no VNC service. So let's publish both the ports now. Okay, so in previous session we have published a specific port because we are just creating a single container. Okay, but using the Docker Compose YAML file, we are going to scale these containers also. That means we can create multiple containers from the same image at the same time. So it is better not to give a specific port like this in the Docker Compose YAML file. just give which port you want to publish from this Docker container, and for the host machine, Docker will publish whatever port available at that time. Okay, so we will use that port to access this two service, VNC service, and 7900 is no VNC service. So let it be like this. Then under environment, we need to add the different environment. So we need to add our SE event bus host, and then one port we need to publish and one port we need to subscribe. So for this value, there will be two Chrome browsers will be running at this Chrome service node container. So I will show you that. And this is the node max session. So how many sessions you want to start in a particular node container? How many max session you can start? So by using this value, you can limit the number of sessions can be started in the single container. So I will put it as 1 as of now. So maximum only one session should start in each node container of this Chrome browser. So let me copy this Chrome service to create a Firefox service and Microsoft Edge service. Okay, so I have created these two services, Firefox service and Microsoft Edge service. So we just need to change the image that we need to use, and all other keys and values will be remain same for each service, right? This ports and environment is same. So you can see that it is very easy to create this Docker Compose YAML file. You just have to add the different services you want to create and different configuration from which these services should be created and started. And this process you need to perform only once. So once this Docker Compose YAML file is ready, you just have to share it with your all team members so that they don't require to remember all these Docker commands for creating the Selenium Grid 4, right? So that is the great advantage of this Docker Compose YAML file, and we are able to scale our containers as well. Okay, so it's very easy to scale this container. So it's time to run this Docker Compose YAML file now. So for that purpose, just go to the folder where you have created this file and open PowerShell from that location. Okay, so let me check if any container or any service is already running or not. Docker ps-a. Okay, so there is no service, no container running. So to run that Docker Compose YAML file, you can simply use this command docker compose and up. So you just have to create the Docker Compose YAML file, add all the services, configuration information in that, and once that file is ready, you just have to remember this single command, docker compose up. Okay, so it is very easy to remember as compared to this lengthy commands, right? And you can use this command only if you have given your file name like this, docker dash compose, but our file name is setup Selenium Grid 4, right? So we need to use F flag here, F, and here need to provide the file name. So our file name is setup Selenium Grid 4. So provide that name here, .yml. So this is our extension, and then up. Okay, so let's run this without detached mode. So here I am not using this -d. So let's see the logs and everything here. So it will just as a first step, it will create a by default network, and inside that network all these services will be created. Okay, so we don't require to create network on ourselves. So in previous session we have created network first, and then we started our containers, right? Docker network create. But in case of Docker Compose YAML file, Docker Compose will create its own network, by default network first, and all the services will be created inside that network. So we can see that network Docker default that is created, and then it has created these containers and services. Okay, so let me open another window of PowerShell so that we can see the list of service now. Docker ps-a. So here we can see that there are 4 containers now. One is for Selenium Hub and 3 node containers. And according to our configuration, it has mapped the port 4445 for the Selenium Hub with the 4444 of the Docker container. And it has mapped a random ports for 5900 for each node container for the VNC service. And no VNC service port number 7900 has been mapped with this different ports for the host machine. Okay, so we can access this VNC service and no VNC service from the host machine itself. Only difference is for VNC you need to use the VNC viewer, and for this no VNC service we can access from the browser itself. Okay, so you will see both the things. So first go and try to access this Selenium Hub at port number 4445 from the host browser. So just go to localhost 4445, and here you will see 3 nodes. One is Firefox, one Edge, and one Chrome. Okay, but for some reason it is not showing the multiple sessions here. Let me check. Okay, so in case of Selenium Grid 4, I don't think we need to give this maximum instances. So SE node max session. So similar to this SE event, we need to provide SE at the beginning, SE underscore node max sessions. This is the small difference you need to remember. And maximum session I can start is, let's say, 2. Okay, so this is the only difference is there in grade 3 and grade 4. So I will copy this thing for other two service. Okay, so let's run this again. So this time we can see that we are able to see only one session here, means maximum concurrency is one. So maximum one session can be run at a time. So we want multiple sessions. So let me first take this down. So instead of up, I will use this down. Okay, so we just have to rerun this command up and -d. So this time I will use the detached mode. So everything will run in background only. We won't be able to see this log this time. So network created, Selenium Hub started. It is starting this 3 service now. So let's go to the browser. Okay, after refresh, you can see it is showing 2 instead of 1. So maximum 2 sessions we can start on this each node. Again, it is showing maximum concurrency is 2, means maximum 2 test cases can be run in parallel on this Chrome node or this Firefox and Edge node. Okay, and the same we can verify from the Docker desktop application. So just expand this and let's check the Chrome service. So you'll be able to see all the logs. So max session is equal to 2. Okay, and if you inspect this, you will be able to see all the environment we have set from the Docker Compose YAML file. So AC event publish port, subscribe port, max session is 2, bus host is Selenium Hub. Okay, so all these values you will be able to see in the Docker desktop application. So there is some issue, it is not showing value for this. Okay, but still we will be able to access it, no problem. So you can see inspect and logs for every service from this application. Okay, cool. So now let's try to run our test case in parallel on this Selenium Grid 4. So we will send 4 test cases to Selenium Hub. Let's try to run on all the 4 on this Chrome browser and let's see what happens. So I'm going to use the same project that we have created in the session 2. So I will suggest if you want to understand how we have created these test cases, how we have configured this to run in parallel, you can go and watch this session number 2. Okay, so here I have pointed my test cases on this Selenium Hub running on this localhost 4445. Okay, using the remote webdriver and using this test.ng.xml file, we just have to set this parallel equal to test. And if I want to run any test case on particular browser, I just have to provide the value here. So first test case I want to run on Chrome, then second also I want to run on Chrome browser, third on Chrome, and fourth will also Chrome. So 4 test cases I am going to give to the Selenium Hub. So Selenium Hub will check that okay, capability is Chrome browser, so it will go and send forward the request to the Chrome node. Okay, so maximum 2 sessions can be started at the same time. So let's run this and let's see how it is running at the Selenium Grid. So you'll be able to see something here. Okay, so it has started 2 sessions at the same time. Okay, so even though we have provided the 4 test case, we have limited 2 sessions at the same time. So it is running 2 test cases at the same time. Okay, so another 2 test cases. Okay, so all the test case has been completed now. And similarly, you can run all these 4 test cases on the Firefox and Edge. Okay, you can try that on your own. So let's try to run all these 4 test cases on different browsers now. So instead of Chrome, I will use Firefox here. So 1 test case on Chrome, 1 on Firefox, and next should be on, let's say, Edge. And 4th, let it be on Chrome. So this time it should start all the 4 test cases because 2 sessions can be started at Chrome and 1 is running at one Firefox and 1 is at Edge. Okay, so this is how you can use this Selenium Grid concept to run your test case in parallel on different browsers at the same time. So that will help you to reduce your test case execution time. And if you want to see the memory usage, you can see it from the stats tab. Okay, so currently it is using 0.4%, around 4%, and memory usage is around 300 MB. So once you start your test case, it will going to increase. So let's quickly see that as well. So if you see, once test case execution will start, you can see these values are increasing now. So it is using more CPU and more memory and the network. So once the test case execution is done, it will come to the normal level. So this is for Firefox service. Okay, so I think test case execution is done on the Firefox. And for Chrome also we can check the same. So on Chrome we are running two sessions at the same time, so it is going to use more CPU and more memory. Okay, and it is using the more network as well. Okay, so this help you if you face any issue while running in a test case, you can check the logs. Okay, you can check the different values of the environment you have provided. Okay, and you can check the memory usage also. So now let me cover the last point, how to scale the containers. So currently we have only one container for each browser. So you can create multiple containers, means you can scale these containers while creating and running this Docker Compose YAML file. So you just have to use the same command here. Okay, only here you need to provide this scale flag, scale, and which service you want to scale. So service name you need to provide. So I want to scale this Chrome service, for example. Chrome service equal to 2. So it is going to recreate this Chrome service only, as we have made change into this. Other services are still running, so we have not made any change into that. So if you go to the browser now, okay, so you can see there are two nodes containers running the Chrome browser now, and we can run two test cases, means two sessions in each node running this Chrome browser. Okay, so this is how you can scale the container. It is very easy. You just have to use this scale flag and provide the service name you need to scale. Okay, so you can provide multiple service also here. Okay, so if you want to scale this Firefox service as well, can do is you can just give it here -- scale equal to Firefox service equal to 2. So it is going to recreate this Firefox service as well this time. So let's wait for a few seconds till the changes reflected in this Selenium grid. So now I can see there are two node containers running the Firefox browser. Okay, so this is how we can easily scale these containers using this Docker Compose YAML file. So in case of this running the Docker commands, we cannot scale the containers. Okay, that is the big disadvantage creating the Selenium grid using this Docker commands. So better option, the best option is to use the Docker Compose YAML file. Just add the services, save that file, and run that file using the simple Docker command. And once your work is done, you can easily take all these services down using this same command. You just have to use the down here. So all the services will be stopped first. Okay, and all the containers will be removed then. Okay, so you can see if you refresh here. Okay, so there is no service running at this localhost 4445 now, right? Okay, and last point, I need to show you the NoVNC service, how we can access it from the browser. So let's try to access NoVNC service for this Chrome node at 53022. So if you go to localhost 53022, you can see here NoVNC service is running. So click on this connect and enter password as secret. Okay, so let me quickly run our test case. Okay, so execution has started on the Chrome. Okay, we have two browsers here, right? So you can see one, and this is the second. Okay, so this is how we can access this NoVNC service right from the host machine browser, because you have published this port. Okay, and for accessing the VNC service, you just have to use the VNC viewer application. So here also, when you just need to add this IP 127 localhost IP 0.0.1 colon and just provide the port. So this time let's access Firefox VNC service at 53026. 53026. So same password we need to add here, secret. Okay, so this is the Firefox Linux container. So let's see if it start the execution. Yeah, it has started now. Okay, cool. So I think that's all for this session, guys. Try to create this Selenium Grid 4 in Docker using this Docker Compose YAML file. Try to create this Docker Compose YAML file on your own, and you don't require to remember this command. Just create this file and run this file, and you can use different values here for this max sessions. You can set to any different values, and for practice purpose, you can create multiple test cases. Okay, so as of now, I just created 4. So you can try creating 10, 20 test cases and try to run in parallel on the Selenium Grid. Hi guys, welcome to the session 9 in the Selenium Grid with Docker series. So in this session, we are going to see how we can run the Selenium test cases on the Docker Selenium Grid on the remote AWS EC2 instance. Okay, so in previous sessions in the playlist, we have already seen how we can do the setup for the Docker Selenium Grid 3, Grid 4 on the local machine, and we have accessed the VNC and no VNC services from the local machine itself. Okay, I have already shown you that how we can do that on the local machine. Okay, this setup. So basically, a Docker Selenium Grid will contain one hub, and hub will connect it to the one or more multiple nodes, means Chrome browser, Firefox, Edge, Opera, like that. So we created this configuration on the local machine on the top of Docker. Okay, we installed the Docker, and then we created this setup, and then we have run our Selenium test cases in sequential or in parallel mode as well, and we have accessed VNC and no VNC services as well on the local machine. So same type of configuration, Docker Selenium Grid, we are going to set up on the remote machine on the AWS cloud, on the AWS EC2 instance. Okay, and once that setup is ready, then we will run our Selenium test cases on that remote machine. And for the live monitoring of the Selenium test, we are going to access this VNC port 5900 and no VNC 7900. First of all, we will require AWS credentials, means you need to sign up for AWS account, and with the help of that, we will log in into the AWS console. Then we will create an EC2 instance on the AWS cloud. Okay, we will start that machine, and after starting, we need to connect to that remote machine. Okay, so for that purpose, we need to create the PEM file, okay, .pem file, and we can connect to that EC2 instance with SSH by using that PEM file. So once we connect to that machine, okay, then we will install the necessary things we will require to run our Selenium test cases. If it is not there, for example, we will require Java, Docker, Docker Compose, right? So we will install if it is not there on the machine. Some machines will already have that software installed. Okay, so we will see that, and once it is done, then we will set up our Docker Selenium Grid on that EC2 instance. And once it is ready, we will run our Selenium test cases sequentially or in parallel mode, and then we will access the live monitoring through the VNC and no VNC services. So just go to the awsamazon.com, and if you are not signed up for this, you can create an account, AWS account from here. Okay, so I have already created that account. So I will directly log in into the console. So once you log into the AWS console, just select the region from here, Asia Pacific Mumbai region. Okay, if it is not selected there. And then from search, we can search EC2 here. Click on EC2. Okay, so this is the EC2 dashboard. So from here, just click on the instance from the left menu, where you will be able to see if you have created any instance for the EC2. So currently I have not created any instance. So let's go and create it. So click on launch instance. Then from the here we will select this checkbox. Okay, free tier. Select it. So I can go with the more CPU. Let's say T2 medium, where I will get 2 CPUs and 4 GB memory. So that is enough for demonstration purpose. So click on this next configuration instant details. So here we don't need to change anything. Okay, number of instance I am going to create is 1, right? So let's directly click on the add storage. So on this add storage, it should be 4, minimum 4. Okay, so by default it is giving 8. Okay, let it be 8. And next is add tags. So from here I can tag my machine. So let's say AWS EC2. My AWS EC2. Okay, so from configuration security group, you can create the different security group here. So by default, they have already added this rule SSH, because we are going to access this remote EC2 instance through the SSH. Okay, so port number 22 is for SSH service. Okay, so from here we are going to access. So from source, we can select my IP only, because I am going to access this machine from my laptop, right? So this is my IP 106.110.252.189. Okay, so from this IP, I am going to access my remote machine. Okay, so this is local machine IP. Okay, so after adding public IP, click on review and launch. So we need to connect to this remote machine from our laptop, right? So for that purpose, you can use an existing key that I have already created, or if you want to create a new one, I can create from this option, create a new key pair. So let me give some name, my AWS key. Click on download. So it will download this file, file name .pem extension. Okay. So once it is done, we need to click on launch instance. Okay, so it will launch, it will start our AWS EC2 instance. So we can go there using this view instances. So once our machine is up and running, then we will connect to this EC2 instance. Okay, So now our EC2 instance is ready. So now we can connect to this EC2 instance. So for that purpose, just go to the download folder where we have downloaded your key. So from here I will open PowerShell. So just run this command ssh space -i, then give your file name. So my file name is, okay, with the extension, not only file name, my aws key.pem space ec2 dash user. Okay, so this is the by default user that will be created for our AWS EC2 instance. At the rate, here you need to give the public IP of your EC2 instance. Okay, so that you can get from here. Just click on this instance ID, and this is your public IP v4 address. Okay, so this IP we will require. So I will copy that IP here, paste it, and hit enter. Okay, so it is asking. So click yes. So permanently added this IP to the list of known host. Okay, that means I am connected to my remote AWS EC2 instance now. So you can become a root user here, sudo su. Okay, now I am root user. So first thing, after you connect to the AWS instance, it is always good idea to update your yum. Okay, so sudo yum update. So with the help of this yum, we will be able to download and install different software or different things on this AWS EC2 instance. Okay, so first let's go and update the yum. Okay, so there is no package for update. Okay, no problem. So we will require Java, Docker Compose. So let me check if it is available or not. Okay, Java command is not found, means Java is not available on this AWS EC2. Okay, so let's go and install the Java. So just use this command to install Java, sudo yum install java dash 1.8.0, okay, dash open jdk, hit enter. So within a few seconds it will install the Java. Okay, click yes. So it will download necessary packages. Okay, it's done now. So we can verify install. Okay, now we have Java on our EC2 instance. So next thing we will require the Docker. Okay, so for that purpose use this sudo yum install Docker. Okay, Docker is installed. So we can check the Docker version now. Docker space -v. So Docker version is 20.10.7. Okay, so we will require Docker Compose as well. Maybe let's check if it is available. Docker Compose v. Okay, Docker Compose command not found. That means Docker Compose is not available here. So we'll require Docker Compose also when we are going to create the Docker Selenium Grid on this machine. So first run this command. So this will install the Docker Compose. Okay, so once it is installed, we need to move the Docker Compose from local bin folder to the user bin folder on the AWS EC2. So we will run this command sudo move mv user local bin Docker Compose, move to the user bin Docker Compose. Okay, user / bin. So now we need to provide the permission to that file. Okay, so now if we check the Docker Compose version, okay, now it will show you the version 1.2.26.0. So until now we have done with these steps. Whatever things we will require, we have already installed on our AWS EC2. So now it is time to set up Docker Selenium Grid. Okay, so for that purpose, I will use the same command that we have used in the previous sessions. So for Selenium Grid 4, first we will create the hub. Okay, so before creating hub and nodes, you need to create the network, right? So for network, we need to use this command. Okay, I will use this command. Okay, Docker network create, and this is my network name. So we need to start the Docker service first. Okay, we have installed the Docker, but we need to start the Docker, right? Docker service. Let me increase the size so that you can see that. Okay, sudo docker service and start. Okay, it is not sudo docker, it is sudo service first. Sudo service, and which service you need to start? Docker service. So docker start. Let me clear this. Okay, so our Docker service has started now. So let us create the network first. Okay, so this is my network name, grid 4 network. Okay, so once our network is ready, we need to create the containers for hub and nodes. Okay, so hub and node container should be in the same network, then only they will be able to communicate. Okay, so this is the command for creating the hub container. So docker run -d-p, and this is the port 4445 of the remote AWS EC2 that I am going to map with the 4444 for inside the Docker container. So the Selenium service which is running at this port 4444 inside the Docker container will be accessible through this port. Okay, and this is the network, grid 4 network that we have created. This is my container name. Okay, and this is the image, Selenium image from which this container will be created. Okay, so first it will check the locally if it is this image is available or not. If it is not available, it will download that image and then it will create the container out of it, and this will be my container name. Okay, so just let me copy this. So we are going to create the Selenium Grid 4, and this is the image version 4.0.0. Okay, hit enter. Okay, so one container is ready. Okay, so you can check that docker ps -a whatever running services. So this is the container ID. Okay, one container is running and its name is Selenium Hub. Okay, so it has mapped this port number 4445 to 4444. Okay, as per our configuration. So our hub is ready. Okay, so we need to create the containers for different nodes. Okay, for Chrome browser, Firefox, Opera, on which we can run our Selenium test cases. Okay, so let us create a few containers. Okay, so for node containers, I need to use this command. Okay, okay, so this is for Chrome node 1. Okay, so for grid 4, we need to use some extra things here. Okay, so publishing or mapping port is same. Your network will be the same, right? So only few things are different. This SE event bus host. So this is my hub name. Okay, so this is for creating the relation or connecting hub nodes with the hub container. Okay, then SE event bus publish port 4442 and SE event bus subscribe port 4443. Okay, and this will be my container name. Okay, and this is the node Chrome 4.0.0 image. Okay, so out of this image, our Chrome node container will be created. Okay, so again it will go and get that image and it will create the container out of it. So it will take few seconds. Okay, our container is ready, Chrome container. So first let's create the container for Firefox. So this will create the container for Firefox. So we will have one hub container connected to the two node container. One is Chrome container and one will be Firefox container. Okay, so let's check the running services now. Docker ps -a. So you can see we have three containers up and running. One is Selenium Hub, one is Chrome, and one is Firefox. Okay. So now we can see we can access the hub service on the port number 4445. So 5900 is your VNC service running at the 5900, and no VNC service will be running at 7900 inside the Docker container. Okay, so we have mapped that port to the 4448. Okay, this is the no VNC port, and VNC service 5900 is mapped to the 4446. So I think I have not published or mapped any port for 5900 for first container, and for second container I have just published the VNC service port. Okay, so what I can do is I can publish some port for both the services. So what I can do is I can publish any other port, let's say 4447 mapped with 7900. Okay, just give -p, and for this node -p 4449 mapped with 900. So let me first remove the running containers and we will create the container again. Okay, so I will go and create these containers again. Okay, so this time it did not download any image, right? So image is already available locally, so it will directly create the container out of it. Okay. Okay, so now we will see it has mapped this 5900 port to the 4449 and 4446. Okay, and 7900 port to the 4448 and 4447. So for accessing VNC service, you will require VNC viewer, and for accessing no VNC service, you can directly access it from the browser itself. So first of all, let's try to access our Selenium Hub service at 4445, right? So to access all these services, we need to use this public IP of our machine. Okay, so this is my public IPv4 address. So I will copy that IP, and you can paste it here, :4445. Okay, so currently I am not able to access that service because I have not added any security group. So if you remember, under security group we have already added a single rule that is by default added by the AWS for the accessing this service, SSH service through 222 port number. Okay, so we need to add one more security rule here, inbound rule, so that we'll be able to access this hub service or no VNC service from the different ports. Okay, so what I can do is I will click on the security group ID. Okay, and I will go here, edit inbound rules. I will click on this add rule. Okay, so from this drop down, type drop down, you can create a custom TCP rule, or you can select this all TCP. So if you select all TCP, it will give you all the TCP port range from 0 to 65535. Okay, so maybe I can create a custom TCP rule here because I don't require all the ports. Okay, so whatever port I am mapping or publishing are only around 4446 is and last one is 4449. Okay, so I can give the range. Okay, I can give some range here, 0 to, let's say, 4450. Maybe I can change this also, 4444 to 4450. Okay, and from the source I'm going to access from that from my machine, right, my IP. So I will select that IP and click on save rules. Okay, so new rule added in the inbound rules. Okay, IPv4 custom TCP, and this is the port range. So only the port from this range will be accessible. Okay, so I have published only the ports between this range, right? My last port is 4449, and from this machine, this is my local machine IP from where I'm going to access different services, right? So now if you refresh the page, you will be able to see this Selenium Grid service we are able to access from this 4445 port, right? And this is the IP of our AWS EC2 instance. Okay, so IP of AWS EC2 instance colon 4445, whatever port you have published. So let's go and run some Selenium test cases on this Selenium Grid. So we have already created this project. Okay, in the previous session you have already seen that. So from this test.ng XML file, I'm going to run two tests. Okay, so from here I'm sending this parameter browser equal to Chrome. So one test I'm going to run on the Chrome browser, and the method it is going to run is this. Okay, this is the method name. And second test I will use the Firefox browser. Okay, so we have one Chrome, one Firefox, and let me show you the Docker Selenium Grid test. Okay, so here just we have used the parameterization in the test.ng concept. Okay, so browser parameter I am going to access from the test.ng XML file. I will pass the value for this browser, and I will use that value from here. So if it is Chrome, then I will set up the capability for browser, set browser name equal to Chrome, browser type.chrome. Okay, and execution will start on the Chrome browser. If it is Firefox, then it will start on the Firefox. And then with the help of remote web driver, we will be able to run our Selenium test on the remote machine. Okay, so currently my remote machine is my AWS EC2 instance, and it will have some IP, right? Okay, so what is my IP and where my service is running? At port number 4445. Okay, so I will copy this whole thing up to the port number. Okay, so this is where my Selenium hub is running. So I will provide my Selenium test to the Selenium hub, right? So what will happen is we will run our Selenium test cases. So hub will receive that test cases, and depending upon your browser type, it will forward those requests to the nodes. Okay, so if it is Chrome, then it will run Selenium test on the Chrome browser. If it is has to be run on Firefox, then it will run on the Firefox browser. Okay, so this is my AWS EC2 instance IP colon 4445. So in the test, we are just opening the google.com, and we are going to assert the title. Okay, Google title. Okay, so we are going to simply open Google and LinkedIn, and we will check the title. Okay. So if your machine is up and running, everything is correct, so it will start running your Selenium test. So one is running on Chrome, one is running on the Firefox. Okay, concurrency 100%. So you can see session here. One is running on the Chrome, one is running on the Firefox. So these tests are running in the parallel mode because I have said this parallel equal to test, right? That's why they are running in the parallel mode. So we can run this test, and let's see how we can access do the live monitoring of the Selenium test cases through the NoVNC and VNC service. Okay, so first let's see through the VNC service. So for that purpose, we will require VNC viewer. So to access this VNC service, I just need to give the IP of remote machine and port number where VNC service is running. Okay, so for first container, our VNC service is running at 4446. Okay, we have mapped this port. So what I can do is, let me copy this whole thing. Okay, and we don't require this HTTP here. Okay, so it will ask you for the password. So just type secret. Okay, so this is the Linux container, Selenium Grid container, and 4449 is for Firefox container. Okay, so now I am able to access the VNC service which is running inside the Docker container. So let's go and run the Selenium test again. Okay, so yeah, so Firefox browser has opened. It has opened the linkedin.com, and on the Chrome we have opened the google.com, and we are checking just the title of the web page. Okay, so this is how we can do the live monitoring through the VNC service by using this VNC viewer. Okay, so let's run this one more time, and we are going to access no VNC service now. So to access the no VNC service, again I will require the IP of our EC2 instance. So let me copy that again to instances. Okay, copy that IP, and which port we have published. The Chrome node no VNC service will be accessed to this 4447, right? So remote machine IP colon 4447. Okay, so this is the no VNC. Click on connect. Here also you need to provide the same password, secret. Okay, so we are able to access this service in the browser itself. And let me access the another container VNC service. So that is the port number 4448. Okay, click on connect, secret. Okay, so now when we run our Selenium test cases, we will be able to see live monitoring from the browser itself. Okay, so why we are able to access this? Because we have published or we have added this security group. So let me run this again. So Selenium Hub has provided or forwarded one request to the Chrome container. So it has gone to the google.com, and one request on the Firefox container. Okay, so we are able to access it to the no VNC service. So you can monitor it, we can click on any link also. Okay, so that means you can interact with the browser also through the service. So once our work is done, we can stop our EC2 instance. So I will select this checkbox and go to the instance state, and I will terminate it. Okay, so I don't require it, so I will click on terminate. So as a summary for this session, if you want to run your Selenium test on the Docker Selenium Grid on the AWS EC2, that is the remote machine, then simply you just have to create the account on AWS. Okay, log in into the AWS console, then launch any EC2 instance. Okay, select the EC2 instance free tier, select a memory and a security group. Okay, when it is added, you need to launch the instance. Okay, so before launching, it will ask you to create the PEM file. So with the help of this key, we will be able to connect to that remote EC2 instance. Okay, with the help of SSH. And once you connect it to that remote machine, then we will install the necessary software. Okay, Java, Docker, Docker Compose. And once it is ready, then we can set up our Docker Selenium Grid using the Docker commands, simple Docker commands. And once that configuration is up and running, then we can run our Selenium test cases in sequentially or in parallel mode as well. And this is important. You can access live monitoring by accessing the VNC and no VNC service. Hi guys, welcome to the next session in Selenium Grid with Docker series. So in this session, I am going to cover how to set up Docker Selenium Grid on AWS EC2 instance using Docker Compose YML file. So we are going to follow the same steps as the previous session. Only difference here will be how we are going to set up Docker Selenium Grid. Okay, so previous session we have used different Docker commands for setting up our Selenium Grid architecture in the Docker, right? So for this, either you can use the Docker commands, okay, or you can use this Docker Compose YML file. Okay, so there are many advantages if you set up your Selenium Grid with this Docker Compose YML file. So for our Selenium Grid architecture, we will require the hub service, okay, and then we require different node services for Chrome, Firefox, then Opera, and there should be a bidirectional communication between all these services. Also, we require to map the different ports also for external connectivity for accessing VNC and no VNC services from outside of the container, right? So all these things you just have to mention in a file. Okay, so that file has a Docker Compose YML file, and by running a very simple Docker command, you will be able to start all these services within few seconds. And another big advantage here will be you will be able to scale your services. For example, if you want to create multiple containers for the same service, you can do it very easily. So only main task here will be you need to create the Docker Compose YAML file for creating the Docker Selenium Grid. Okay, so that we have already seen in detail how you can create it in the previous sessions. Okay, so I am going to directly use that file this time, and we are going to set up this Selenium Grid architecture on the AWS EC2 instance. So first let's log in into our AWS account and get our EC2 instance ready. Okay. So once you logged in into your Amazon console, you can click this recently visited link, or you can search here EC2. Then from this instance, we can see there is no instance created. So let's click on the launch instance. So from here, we can use this pre-tier eligible. Okay, this is Amazon Linux 2 AMI. So maybe we can use another machine where all the other things in Java, Docker Compose are already installed. So if you use this, this machine do not have any Java or Docker Compose. So you need to use different commands to install this software first before setting up our Docker Selenium Grid. Okay, so that we have seen in the previous session. So let's try to search other AMI which have pre-installed Java, Docker Compose. Okay, so I will simply search here Docker Compose. So I think these machines already have this build kit, agent, Docker Compose already there. Okay, so let's try to use this machine now. So let's click on the select. Okay, so let's go for T2 medium. Configure instance details. So number of instances 1, right? So no need to change anything here. Okay, and directly click on add tags. Security group. So under this security group, you need to add different inbound rules. Okay, so that you can access VNC and no VNC. So I will click on add rule, and from this you can select all TCP or custom TCP. And I will give some port range. Let's say 02. As I am going to use the Docker Compose, what I can do is I will select all TCP. Okay, so why I am selecting this all TCP is because I am going to get this whole port range. Okay, 0265535. So as we are going to use the Docker Compose YAML file for starting different services for our Selenium Grid, the whatever port it is available for that Amazon EC2 instance will be mapped to the Docker container port. Okay, so I am not sure what port it will be mapped, right? So that port will be in between this range 0265535. Okay, so you can select this all TCP, and this is the by default range it will provide. And from source, I am going to access it from the my PC only, means my laptop. So this is my local machine IP. Review and launch. So click on the launch. So from here I can use any existing key pair or I can create a new key pair. Okay, so I will use the existing one. So I have already created this key in the last session, my AWS key. Yes, I will use it. Launch instance. Okay, so within a few seconds our Amazon EC2 instance will be ready to use. So click on view instances. So instance state is now running. Okay, that means our Amazon EC2 machine is ready to connect. So let's click on instance ID, and this is the public IPv4 address. Okay, so using this address we can connect to this Amazon EC2 instance, that is the remote machine from our own laptop. So let's connect to this remote EC2 instance from our local machine. So just go to the folder where you have downloaded the .pem file. And from here I will open the PowerShell. So just run this simple command SSH. Okay, so we are going to connect to that machine using SSH and .pem file. SSH space -i, then give the file name. Space EC2 user. So this is the by default user created. At the rate, give the IP of your Amazon EC2 instance. So my public IPv4 address. So just copy that address and paste it here. Okay. So now we are connected to our remote EC2 instance now. So it is saying run sudo yum update to apply all the updates. Okay, so once you connect to your remote machine, it's always good practice to run this command sudo yum update. Okay, so with the help of yum, we can install another or different softwares whatever you require on this Amazon EC2 instance. Okay, so after completing, let's try to see if Java, Docker Compose are available or not. Then let's check the Docker version. Docker version 17 is already available, and let's try to find the Docker Compose. Okay, so Docker Compose is also available. Okay, so all the things whatever we require to create and run our Selenium test cases are already available and pre-installed on this Amazon EC2 instance. If it is not there, I have already shown in the previous session how we can install Java, Docker and Docker Compose if it is not available. So let me clear this first. Okay, so now we just need to run the Docker Compose YAML file. So first let me show you the Docker Compose file that we are going to use. So this is the Selenium Grid Docker Compose YAML file, and in this YAML file I have mentioned the different services that I want to create. Okay, under these services. So first of all I need a hub service. Okay, so hub service will be created, means the Docker container will be created out of this image. Okay, Selenium/hub 4.0.0, and these are the ports I am going to publish. Okay, this is the container name. Then another service I require will be the node services. So different nodes I am going to create are a Chrome service. Okay, so that container will be created out of this image, right? and these are the ports we are going to publish. So 5900 is for VNC and 7900 is for accessing the no VNC service which is running inside the Docker container. And different environment required we need to mention under this environment key, okay, for connecting this node to the hub service, and this service is completely dependent upon the hub service, right? So similarly we have mentioned the Firefox service and Edge service. So all these three node services are completely dependent upon this hub service, okay. So this is the simple Docker Compose YAML file that we are going to run. So this file is currently available on my local machine, and I can run this file and create the Selenium Grid architecture on my local machine on the Docker. But I want to create this architecture on the remote machine, not on my local machine, right? So first I need to create this file on my EC2 instance remote machine. Once this file is available there, then I can simply run a Docker command to run this file. So first step is to create this Docker Compose YAML file on the remote machine. So currently if I see what are the different files available on my remote machine, okay, there is only one directory, Docker directory. Okay, so first I need to create this Docker Compose YAML file, and we will simply copy and paste this content into that file. Okay, so for creating any file on your remote machine, use this command touch, and for your Docker Compose, give this file name docker compose.yml. Okay, so this will create a file in this current directory. So see now this file has been created. So this file is an empty file now. Okay, it do not have anything. So what I have to do is I need to open that file in VI editor. Okay, and we will simply copy all this content and paste into that file. Okay, so once you are done, press escape, then :WQ. Okay, so now our Docker Compose YAML file is ready on our remote machine. So we just need to run this Docker Compose YAML file for starting all those services. Okay, so within a few seconds, our Selenium Grid architecture will be ready in our Docker on Amazon EC2 instance. So to run this Docker Compose YAML file, simply run this command docker compose space up. Okay, so first it will start a default network, okay, and then one by one it will start creating the services. So for starting or for creating the services, it will require the images. So it will download whatever image you have mentioned in your Docker Compose YAML file. Okay, so for hub service, it will go and download this image, and then after downloading, it will create container out of it. Okay, and same for other node services. Okay, so these images will not be available locally at the first place. Okay, we are setting the Selenium Grid architecture for the first time, right, on the EC2 instance. Okay, so that's why these images are not available locally. So it will go and download these images first. Okay, it will pull the images and then create the container. So until all the containers are ready, let me show you this ports mapping. So here we have published all these ports for the hub service, and for creating the containers for the node services, we have mapped 5900 and 7900 with whatever port available. Okay, so here I have not hard coded any port for the host machine. Okay, so I can map like this also. But if you map like this, that will be hard coded value. And if you want to scale this service, okay, if you want to scale means if you want to create multiple container for same service, it cannot map the same port, right, for the multiple services. So that's why I do not mention any port hard coded value here. It will Docker will map whatever port available at that time from the host machine to the Docker container port. This 5900 and 7900. So I think all the services are up and running now. Okay, so let me open another window for the PowerShell. So first let's check the running services. Docker ps-a. So you can see we have this hub service and 3 node services, Chrome, Firefox and Edge. And let's quickly see what are the different ports it has mapped. So 5900 port mapped with 32773. Okay, so this is for first container. For second container, this port has been mapped, and this is for third container. Okay, so it has randomly selected port whatever available at that time, and same for the no VNC services. Okay, so to access this hub service, I will simply go to the browser. Then I need this IP, right? So I will copy this IP for my remote machine. So that IP : 4445. Okay, so this is the port, and this is the IP where my Selenium Grid service is running, and these are the 3 nodes connected to our Selenium hub. Okay, so we have Firefox, one is Chrome, and one is Edge. Okay, so you can simply run your Selenium test cases on these browsers now. Okay, just provide your Selenium test cases to the Selenium hub running at this address. Okay, and that hub will forward that all the requests depending upon your browser type to the Firefox, Chrome, and Edge. So now let's run some Selenium test cases on these nodes. So we are going to use the same project that we have created in the previous session. So I will simply provide the address where my Selenium hub is running. Okay, so my Selenium hub is running at this IP, and this is the port number. So I will simply copy it and add it here. Okay, and through test.ng XML file, I will provide the browser name. So this test should run on the Chrome, second on Firefox. I will run this third test on the Edge. So another we have on the Chrome. Okay, so currently we have 4 tests. So 2 will run on the Chrome and 1 on Firefox and 1 on Edge browser. Okay, so our tests are running. So we have these two sessions for the Chrome. So 2 sessions will run at the same time. So you can monitor all these tests also by accessing your no VNC service from the browser or VNC service from the VNC viewer. Okay, so let me show you the no VNC. So for that purpose, you just require the port number. So for no VNC service, the 7900 is mapped with 32772. Okay, so we require this port number if you want to access the no VNC service from the browser. So I will use the same. Okay, so we require the remote machine IP colon whatever port the Docker has mapped. So we will use this 32772. 32772. So add here secret, and another one is 32770. 32770. Three two seven six eight. So let us run the test again one more time. Okay, execution has started. So this is the Microsoft Edge, Firefox, and Chrome browser. Okay, so this is the live monitoring. You can access and see how your tests are running, and you can interact with the browser also. Okay, so with the help of Docker Compose YAML file, I can very easily scale these services. So currently I only have one Chrome, one Firefox, and one Edge. So I can create multiple instances for this Chrome, Firefox, and Edge by scaling the service. Okay, so what we can do is okay, let me connect to our machine again. Okay, so I will take this configuration down first. So use Docker Compose down. Okay, so it will take all the services, it will stop all the services. Okay, and again I will use Docker Compose space up and then use this flag scale and provide the service name we want to scale. So from our Docker Compose YAML file, we have Chrome service, we have Firefox service, and Edge service. So let's say I want to scale this Chrome service. I will copy that service name. Okay, Chrome service, and I want to create, let's say, 2 instance. Okay, you can scale another service also. Scale. Let's scale this Firefox service also. Equal to, let's say, 3. So we are using the same command for running the Docker Compose YAML file, but only we are mentioning here the scaling. Means using the scale flag, I want to create 2 instances for this Chrome service and 3 instances for the Firefox service. Space, I will use the test mode this time. So within a few seconds, our architecture will be ready. Okay, everything is ready now. So you can check that Docker ps-a. So now we can see we have multiple nodes now. Okay, so we have Chrome service 1, Chrome service 2, and for Firefox we have 1, 2, and Firefox 3. Right, and for Edge we have only one container. And same we can verify from the browser. Okay, so here you can see we have 2 Chrome and we have this 3 Firefox. Okay, so as we will have the multiple instance for this node containers, Hub can directly forward this request to the whatever available nodes. Okay, you do not have to wait for current node to get free. Okay, so it has 2 Chrome, it has 3 Firefox. So 3 tests can be run on in parallel mode on these 3 Firefox browsers. So you just need to follow these simple steps. Okay, create account for AWS if you are not created, and launch the EC2 instance. Okay, so while launching you can create a free tier machine, but there you may require to download and install Java, Docker Compose. Okay, but if you selected an EC2 instance which have all the software pre-installed, then you don't require to install it again. You can directly create the Docker Compose YAML file and run it. Okay, so you just need to connect to that remote EC2 instance, get the public IPv4 address of that machine, okay, and connect with the SSH. Okay, so for that purpose, first download the PEM file, and with the help of the PEM file, you will be able to connect to that remote machine. And once you connected, you just have to set up this Docker Selenium Grid by using this Docker Compose YAML file. And you can do this live monitoring by using the your remote machine IP and whatever port we have mapped for this VNC and no VNC services. Okay. And for scaling any service from the Docker Compose YAML file, you just need to use this command. Okay, scale flag. Docker Compose up and use the scale flag. Then provide the service name equal to whatever number of instances you want to create. Okay, so you can create multiple or you can scale multiple services at the same time. So within a few seconds, whole Selenium Grid architecture will be ready for use. Okay, and then you can run your Selenium test cases. Hello guys, welcome to the next session in Selenium Grid Docker series. So previously we have seen how we can set up the Selenium Grid in the Docker and how we can run our Selenium test cases from local machine or in the AWS EC2 instance as well. Okay, so now we are going to see how we can record the test execution which is happening in the Docker container. Okay, that means if you are running your test cases, Selenium test cases on the Docker, on the Chrome browser or Firefox or Edge browser, so I need to record that test execution so that it will help me to debug any issues, okay, related to the application. So normally we run our test automation in the night only, right? So when we are in the office, we will get the test case execution report, okay, automation report. So in night we cannot do the live monitoring for each and every test cases, right? So if any test case is failing and if we turn on the video recording for the test case, then we can easily able to see what exactly happening while watching that recorded video, right? So this will definitely help you in your real-time project as well. So what we have to do is you need to follow the simple steps. You need to create a Docker Compose YAML file and we need to add the required services. Okay, so we have already created the Docker Compose YAML file in previous sessions. So same you will see how we can use it. And we need to set up this Docker Selenium Grid with a Docker Compose file. Okay, then we will run our Selenium test cases. And once our test case execution is done, we will get the recorded video on our local machine. Okay, so let's start now. So this is the Docker Compose YAML file we are going to use for this demonstration. So here I have added two services. One is for our Selenium Hub service. Okay, this is the Hub service and another one is for Chrome service. Okay, so I will show you how you can record the test execution happening on the Chrome browser, and same steps you need to follow for recording the video on the Edge browser or Firefox browser. Okay, you just need to add those services in this Docker Compose YAML file. Okay, so in Hub service, what we have for creating the container for our Hub service, I have written that use this image. Okay, so on local machine, if this image is not available, it will go to the Docker Hub and it will pull that image and it will create container out of it. Okay, so these are the ports we are exposing. So our Selenium Grid, the Selenium Hub will run on this 4445. Okay, so you will be able to access that service from this local machine 4445 port. Okay, then we have added the Chrome service for creating our Chrome node container. Okay, so both these services will be created. These two containers will be available in the same network. Okay, same Docker network, so that they can communicate. So for creating the Chrome node, this is the image that it is going to use. Okay, this is the latest Chrome service or Chrome node image available on the Docker Hub. And these are the ports we are exposing. Okay, so 5900 and 7900 VNC and no VNC ports, and these are the environment setting you need to add here. Okay, so this Chrome service is depend upon the Hub service. Okay, this Hub service. So for recording the video on the Chrome, you just need to add this service. So for this service, this is the service name Chrome_video, and this is the image it is going to use, Selenium Video FFmpeg. Okay, this is the latest image for this service. Okay, and these are the volumes. Okay, so here we will get the video in this folder only. Okay, /test recordings. So this folder will be created in our local machine where your Docker Compose YAML file is available. Okay, so there it will create this folder automatically, and whatever video recording you will get at the end of test execution, that will be available in this folder in the .mp4 format. Okay, so this service is depend upon the Chrome service, right? And these are the environments. So our display container name is Chrome service. Okay, so this is for Chrome. So we need to record the video what is test execution happening on the Chrome browser. So you need to provide the Chrome service here, and this is the file name. So you can give any file name here. Okay, test on Chrome video1.mp4. So this will be the file name after test execution is done. Okay, so this is done for the Chrome browser. So if you want to record the video on the Edge browser or Firefox, you can. So you need to follow the same approach. You just need to add the Edge service, Firefox service, and then Edge video and Firefox video. Okay, in similar fashion. So now let's go and create and run these services. Okay, by running this Docker Compose YAML file. Okay, so just go to the location where this Docker Compose YAML file is available. So this is the location. So from here I will open my PowerShell. So before running our Docker Compose YAML file, you need to start the Docker desktop application on the Windows machine. So I have started this Docker desktop application. So Docker engine is up and running now. So to run the Docker Compose YAML file, we just need to use this command docker compose space -f and just provide the Docker Compose file name .yml and up and -d. Okay, so first it will pull all the images first. Okay, so currently all these images for hub service, Chrome service and this Chrome video service are already available on my local machine. Okay, so in your case it will go to the Docker hub and pull all these images. Okay, all these are the latest images. Okay, so it will take some time in your case, and when all the images are downloaded, then it will create the container out of it and it will start all those containers. Okay, so if you see all the running containers now, so these are the containers, these are the images out of which these containers are created. Okay, so here you will see different ports that are exposed. Okay, so we can access VNC and NoVNC service from these ports using this port number. Okay, so let's see first our hub that will be accessible on our local machine. So just type 127.0.1:4445. Okay, so this is our Selenium Grid up and running, and here you can see one Chrome node is connected. So if we added the Edge service and Firefox service, those nodes will also be shown here. Okay, so now let's go and run any one Selenium test case on this Chrome node, and we will see how we can record the video now. So this is the project we are going to use. So same project we have used in our whole playlist, right? So here what we are going to do is we are sending the browser parameter from the test.ng.xml file for our test case. Okay, so depending upon the browser parameter, we are going to set the capabilities for the browser type. Okay, so if it is Chrome, then we are going to open the Chrome and our test case execution will start on the Chrome. Okay, if it is Firefox, then it will open the Firefox. Then if it is Edge, then it will set up the browser capabilities to the Edge. Okay, so once it is done, we need to set driver is equal to new remote web driver, and here I need to provide the IP. Okay, so currently we are running on our local machine. So in case if you are running on the AWS EC2 instance, you need to provide that public IP over here. Okay, so 127.0.0.1:4445. Okay, so this is the location where our Selenium Hub service is running. Okay, so once it is done, we will provide our Selenium test cases to the Selenium Hub. So depending upon the browser type, Selenium Hub will forward the test case execution request to the particular node. So if it is Chrome browser, then it will send a request to the Chrome node. If it is Firefox, then it will send the request to the Firefox running node. So in that case, what we are doing is we just simply opening the google.com. We are asserting the title of the page, and we will search one string here in the Google search box. Okay, automation testing, and we will click on the search box. Okay, so after waiting 5 seconds, we are going to get the text of the first link. Okay, so whatever result will be shown after you press the Google search, then you will get some result, and from that result we are going to print the text. Okay, whatever text we are getting at the first link in the console. So this is the simple test that will happen or that will run on the Chrome browser, and that same execution we need to record. So for running this test.ng test, you need to use the test.ng.xml file. So here I am sending this parameter browser and value is Chrome. So for this test, we are going to run this method Google Chrome test. So before running the test case, make sure your Selenium Hub and all the containers are up and running. Okay, so we have seen that from the PowerShell, and same you can see from the Docker desktop application as well. Okay, so you can see the logs as well. Okay, so for the Selenium video container, you will see this is the location where we are going to get the video inside the container. Okay, same video will be available in our local machine. So on the local machine, if you see inside this folder, we have this Docker compose YAML file. Okay, that we have run. So you can see this folder is automatically generated and we started that container. Okay, so inside this container, you will get this video with this name. Okay, so currently this video is empty. Okay, so let's go and run our Selenium test case, and it will record the video. So test case execution started on the Chrome. So on the grid you can see one session has started, and you can do the live monitoring from here also. So just add secret here. So it says automation testing, and it will get this text, the first one. So after waiting 10 seconds, we are closing the browser. So in the console, let's see if we get the output. Okay, so here you can see text is automation testing tutorial. What is automation testing? Okay, so our test case execution has done, and now it is time to see the recorded video. So this recorded video is not yet ready. So we need to stop that video recording container so that video will be available on our local machine. Okay, so we'll need to stop the container for this video. Okay, so to stop the container, just use docker stop and use the container ID, that is 17. Okay, container has stopped now. So now if we go to the local machine, now we'll see 4.64 MB file. So just open this video in VLC player. So you will see actual time for this video is 9 minutes. Okay, so it has started the recording when we start our containers. Okay, so it has opened the Chrome browser. It will go to the google.com, search the automation testing, and it will fetch this first link. Okay, so this is the test case execution that actually happened on our Chrome node. Okay, so it is very helpful feature from the Selenium Grid, Grid 4. okay, so that you can record your test case execution which is happening in the night automation, okay, and using those videos that will definitely help you to debug the issues. Okay, so I have shown you how we can do it for the Chrome. So you just need to add the different services for the Edge and Firefox in the Docker Compose YAML file and add the Edge video and Firefox video similar to this. Okay, so that video will be available on your local machine under this whatever folder name you have provided. So this folder name will be auto generated on our local machine, and you need to stop the container first. Okay, so before stopping the container, you will not be able to play that video. Okay, so using docker stop and container ID, you need to stop the container, and then that video will be available on our local machine.